Welcome to 30 Python Automation Interview Question and Answers for Freshers.
You might think automation roles are meant for experienced DevOps engineers, but the reality has changed. Today, companies want freshers who can write small but smart Python scripts that remove repetitive work. Whether it's cleaning up logs, triggering CI/CD builds, or validating API responses, automation skill is now the new literacy for tech beginners. In this video, we'll cover 30 high-impact interview questions designed to make you sound confident, capable, and industry-ready. Each answer follows the proven, good to better to best framework, combining real scripts, follow-up curveballs, and professional reasoning. By the end, you'll not only know what to say in an interview, but also how to explain it like a working automation engineer.
1. What makes Python ideal for automation tasks?
Answer. Good answer. Python is ideal for automation because it is easy to read, has many built-in libraries, and can be used for a wide range of tasks. Review of the answer. This answer is correct but generic. It lacks real reasoning and practical context. Interviewers expect you to connect language features to real automation use cases.
Better answer. Readability, rich libraries, and cross-platform portability.
Python stands out because of its simplicity, massive standard library, and platform independence. Its clean syntax makes it easy to maintain large scripts, while libraries like OS, subprocess, and requests handle common automation workflows. The same script runs on Windows, Linux, or Mac OS without any modification, which makes it incredibly versatile for system and network automation. Review of the answer. This version adds structure and logic. However, to truly impress, we should demonstrate how Python interacts with real DevOps systems like Jenkins or AWS.
Best answer. Connecting Python's versatility with DevOps and CI/CD workflows.
Python is ideal for automation because it integrates seamlessly with every layer of modern infrastructure. It can trigger builds in Jenkins via REST APIs, manage AWS infrastructure through Boto 3, and parse massive log files automatically. Python's ecosystem lets you control servers, APIs, and deployment pipelines, all from one lightweight script. In production, I've seen teams replace dozens of manual deployment steps with 20 to 30 lines of Python. This combination of readability, modularity, and integration power is exactly why DevOps and SRE teams rely on Python for automation. Review of the answer. This answer sounds confident and experienced. It conveys both technical capability and operational awareness, a perfect mix for fresher-level interviews. Here is the code that triggers a Jenkins build automatically using Python's requests module. Disclaimer: always test code in a non-production environment. Here is the endpoint of a Jenkins job you want to trigger. Each Jenkins project exposes its own unique build URL that can be invoked remotely from your automation script. Here is where you define your authentication section. Jenkins doesn't use passwords for automation. API tokens like this provide secure, programmatic access to trigger builds. This is the heart of the automation. Python sends an authenticated POST request to Jenkins, triggering the build process instantly without manual intervention. Here's the validation checkpoint. Jenkins returns HTTP 201, created, when it accepts the build trigger successfully. You could also log the build number for traceability. Here's the feedback line. This print statement confirms the build trigger succeeded. In real pipelines, you might replace this with a Slack or email alert for better visibility.
Curveball. What if the Jenkins server requires CSRF protection or network access is restricted?
In that case, Python's flexibility shines again. You can first request a CSRF CRUM from Jenkins using the same requests library, then include it as a header in the POST request. For offline environments, you can trigger local builds through the Jenkins CLI instead of HTTP calls. These adaptations show deep operational awareness, the kind that instantly impresses interviewers.
Why interviewers ask this question most often?
This question checks whether candidates understand Python as a practical automation tool, not just as a syntax playground. The best answers connect simplicity, integration, and real-world use cases, like Jenkins, AWS, or monitoring.
Which companies ask this question more often?
1. Tech product firms, Google, Atlassian, ServiceNow, evaluate depth of conceptual clarity. 2. DevOps-heavy organizations, AWS, IBM, Red Hat, expect you to reference CI/CD or cloud automation. 3. Service-based companies, Infosys, TCS, Cognizant, test awareness of common Python modules for automation. 4. Cloud-native startups, check your ability to connect Python with build pipelines or monitoring systems.
2. How do you read and write files safely in Python, using context managers?
Answer. Good answer. You can use Python's built-in open parentheses function to read and write files. For example, R mode opens a file for reading and W mode for writing. Review of the answer. This is technically correct but incomplete. It doesn't show awareness of file safety, error handling, or automation best practices, key points that differentiate a beginner from a professional script author.
Better answer, using context managers to avoid file leaks.
A better approach is to use Python's context manager, with open parentheses. It ensures the file is automatically closed after operations, even if an error occurs. This pattern prevents resource leaks and makes code cleaner. It's especially useful in automation where scripts handle multiple files like logs or configuration files. Review of the answer. This shows a good understanding of safe file handling. It explains both syntax and reason, readability, reliability, and automatic cleanup. But to make it impressive, we must show real-world context and error handling.
Best answer, file handling with exception management and large file awareness.
In automation, file operations often involve logs or large configuration files. A safe approach combines context managers with try-except blocks for controlled exception handling. For instance, you might read a log file line by line to avoid memory overload, handle file not found error, and log all events instead of crashing. This shows maturity and production awareness. Review of the answer. This answer balances readability with robustness. It not only uses the right syntax but also demonstrates proactive risk handling, exactly what interviewers expect from a fresher who understands DevOps-grade automation. Here is the code that safely reads and writes files using Python's context managers and error handling. Disclaimer: always test code in a non-production environment. Here is the import that brings in Python's logging module, essential for recording automation activity instead of just printing to the console. Here is where we configure the logging system. It sends all logs to file_ops.log, which helps you debug file operations later. Here's the context manager that safely opens a file for reading. The with statement ensures the file closes automatically, even if an exception occurs. Here is the loop that reads the file line by line. This pattern avoids loading large files entirely into memory, preventing crashes. Here is the section that writes to another file. Again, the context manager guarantees safe closure and avoids data corruption. Here is where we gracefully handle missing input files. Instead of crashing, we log the error and continue execution safely. Here's how we manage permission issues, common in automated deployments when file access rights are restricted. Here is the final safety net. It captures any unhandled exception with a complete traceback for debugging.
Curveball: what if your script writes logs continuously and the file grows too large?
In production, use Python's rotating file handler to limit log file size. You can configure it to automatically create new log files once the old one reaches a certain size. This prevents disk overflow and ensures long-running automation stays stable.
Why interviewers ask this question most often?
Interviewers ask this to test your reliability mindset. Anyone can open a file, but professionals handle it safely. They look for your understanding of context managers, exception handling, and logging, all of which show production-grade thinking even at a fresher level.
Which companies ask this question more often?
1. Enterprise software firms, Oracle, SAP, IBM, focus on safety and reliability in automation scripts. 2. Service integrators, TCS, Wipro, Infosys, test context managers and exception handling syntax. 3. Product-based DevOps teams, Red Hat, Atlassian, AWS, check if you understand file operations under system constraints. 4. Fintech and analytics startups, look for resilience and logging awareness during automation.
3. What is the difference between lists, tuples, and dictionaries in Python, and how are they used in automation scripts?
Answer. Good answer. Lists are ordered and mutable, tuples are ordered but immutable, and dictionaries store data as key-value pairs. Review of the answer. This is technically correct but mechanical. It shows you memorize the definitions without demonstrating how each structure contributes to automation tasks, a missed opportunity to show practical understanding.
Better answer, choosing data structures based on use case.
In automation scripts, lists are used when you need to store collections that might change, for example, IP addresses or file names. Tuples are used when data shouldn't be modified, such as fixed server credentials or static configuration entries. Dictionaries are best for representing structured data like JSON objects, configuration mappings, or key-value lookups. Each data structure serves a specific operational purpose. Review of the answer. This version moves beyond theory, it connects each data structure to real-world automation contexts. Still, it lacks an example to show how they work together in a practical script.
Best answer, combining lists, tuples, and dictionaries in real automation scenarios.
In production-grade automation, these data structures are often combined. For example, a list can hold multiple dictionaries, each representing a server, while a tuple might hold immutable connection parameters. This combination allows dynamic yet controlled automation. For instance, you might iterate over a list of server dictionaries and execute remote commands while keeping fixed settings secure. Review of the answer. This answer demonstrates practical thinking, not just knowing data types, but designing structures that make automation efficient and predictable. Here is the code that demonstrates how lists, tuples, and dictionaries work together in automation scripts. Disclaimer: always test code in a non-production environment. Here is the tuple that holds immutable connection data, username, password, and port. Since tuples can't be modified, they ensure consistent credentials across operations. Here is the start of a list. Each element in this list will represent a different server. Lists are ideal for storing dynamic collections that may grow or shrink. Here's one dictionary item within the list. It maps server IP and its functional role. Dictionaries are perfect for structured, labeled data. Here's the loop that iterates through the list of server dictionaries, a common pattern in automation scripts that perform repeated actions on multiple targets. Here's the line that simulates connecting to each server. It pulls dynamic data from the dictionary and static data from the tuple, showing how these structures complement each other.
Curveball, how would you modify this if server roles changed dynamically during execution?
You can use dictionary updates or deep copies. For example, use server.update, role, backup, to change roles on the fly without replacing the entire object. But if the role data is shared across scripts, make deep copies to avoid unintended global modifications, a key distinction that shows your maturity in handling mutable data.
Why interviewers ask this question most often?
This question tests your understanding of not just data structures, but data design. Interviewers want to see if you can pick the right data type for the job, especially in automation, where clarity and control reduce risk. Strong candidates explain how lists, tuples, and dictionaries interact logically in scripts.
Which companies ask this question more often?
1. IT service companies, Infosys, Cognizant, Wipro, test conceptual clarity on core Python constructs. 2. Product-based DevOps teams, Atlassian, AWS, HashiCorp, assess how you model real-world infrastructure data. 3. Fintech and analytics startups, expect efficient data handling in configuration and reporting scripts. 4. Cloud-native SRE teams, Google, Red Hat, look for your ability to represent systems as structured data.
4. How do you handle errors gracefully in Python automation?
Answer: good answer. You can use try and except blocks to catch errors in Python. For example, wrapping your code in a try except prevents it from crashing. Review of the answer: this is correct but generic. It only shows surface knowledge. Interviewers expect you to discuss how you log, recover, and handle specific exceptions that can occur in automation, not just catch them blindly.
Better answer: using specific exceptions and logging to improve reliability.
In automation, not all errors are equal. For example, a file not found error needs a different response than a timeout error. Using specific exceptions helps your script respond intelligently. You can also log these events instead of printing them, so you have a record of what failed and why. Review of the answer: this version is much stronger. It demonstrates technical understanding and introduces maintainability through logging. But to make it truly production grade, we must show how to recover automatically and maintain uptime in the face of unexpected failures.
Best answer: handling failures proactively with recovery and alerts.
In real DevOps environments, automation scripts should never crash silently. They should handle failures gracefully, retry operations, log errors with timestamps, and alert the user or monitoring system if something goes wrong. For example, you can catch network errors, retry a few times, and then notify via email or Slack if the issue persists. This transforms a simple script into a resilient automation service. Review of the answer: this answer communicates maturity. It shows foresight and understanding that automation doesn't just mean writing code, it means ensuring the system can self-heal and communicate failures proactively. Here is the code that demonstrates graceful error handling, logging, and retry logic in automation. Disclaimer: always test code in a non-production environment. Here are the imports required: logging for structured error tracking, time for retry intervals, and requests for network calls. Together they form the backbone of reliable automation. Here is where we configure detailed logging. The format includes timestamps and levels, giving clear visibility into what failed and when. Here's the retry loop: instead of quitting on the first failure, the script automatically retries the operation multiple times to recover from temporary issues. Here's the actual operation being performed, checking the status of a server endpoint with a timeout safeguard to avoid indefinite hangs. Here's how we handle timeouts gracefully. The script logs a warning, waits briefly, and retries, a perfect example of resilience. Here's where we handle HTTP-specific failures like 404 or 500 errors. The script logs them with context and safely exits instead of breaking unpredictably. Here's the final fallback: it captures any unanticipated errors with full tracebacks, making debugging straightforward. Here's the escalation logic: when all retries fail, this line flags the event as critical. In production, this is where you'd send an alert via email, Slack, or PagerDuty.
Curveball: what if logging fails or the script itself crashes during error handling?
In production, logging can fail due to permission or disk space issues. To prevent this, always use a secondary fallback like console printing or an in-memory log queue. This ensures your script never fails silently. Even the failure of failure handling must be handled. That's true reliability thinking.
Why interviewers ask this question most often?
Error handling is where real-world reliability begins. Interviewers use this question to see if you understand the importance of predictable recovery. Freshers who mention retries, logging, and proactive alerting show they think like mature DevOps engineers, not just coders.
Which companies ask this question more often?
1. Cloud-native teams, AWS, Azure, GCP, focus on fault tolerance and uptime. 2. DevOps-driven product companies, Netflix, Atlassian, ServiceNow, look for alerting and resilience thinking. 3. Enterprise automation teams, IBM, Accenture, Infosys, emphasize graceful error handling in production pipelines. 4. Fintech platforms, Stripe, Paytm, Goldman Sachs, prioritize predictable recovery under stress conditions.
5. How can you run a Python script automatically on schedule?
Answer. Good answer. You can use the system scheduler like cron on Linux or task scheduler on Windows to run Python scripts at specific times. Review of the answer. This answer is basic and factually correct but shallow. It doesn't show automation maturity. Interviewers expect you to also understand in-code scheduling and monitoring, not just system-level scheduling.
Better answer. Using Python's schedule library for code-based automation.
You can schedule scripts directly within Python using the schedule library. This is great for simple or containerized automation because it doesn't depend on OS-level tools. You define tasks in code and let the script manage its timing loop. This is cleaner and more portable, especially for cloud-based micro-automations. Review of the answer. This version demonstrates real initiative and self-sufficiency. It shows that you can create self-running automations without relying solely on system configuration. Here is the code that schedules a Python task to run every 10 seconds using the schedule library. Disclaimer: always test code in a non-production environment. Here are the required imports. The schedule library handles timing, while time keeps the loop responsive. Here is where you define the automation function. It can contain any task, file cleanup, API checks, or backups. Here's the scheduling instruction. It runs the defined job every 10 seconds. You can replace this with minutes parentheses, hours parentheses, or specific time triggers. Here is the continuous loop that checks for pending tasks. This keeps the scheduler alive, like a mini automation daemon. Here is a small delay between checks to prevent CPU overuse while maintaining responsiveness.
Best answer: integrating scheduling with monitoring and alerts.
In production, I integrate schedulers with monitoring. For example, if a scheduled job fails, the script sends an email or Slack notification using smplib or webhooks. This ensures automation reliability and immediate feedback when something goes wrong. Review of the answer. This elevates a basic scheduling answer into DevOps territory. It combines scheduling, error handling, and alerting, the complete automation loop. Here is the code that extends scheduling with email alerts on failure. Disclaimer: always test code in a non-production environment. Here are the imports that allow the script to send email alerts, that a smplib handles mail transfer, and MIME-text structures the email body. Here is a simulated failure to demonstrate alert handling. In real automation, this could be a failed API call or script error. Here is where the failure message is created. The email body contains the actual error details. Here is the SMTP connection. The script connects to a mail server and sends the alert message automatically. Here's the scheduling part. This job runs every 30 seconds, continuously checking and reporting its own health.
Curveball: what if the scheduler stops when the system reboots?
In production, this is a common issue. To make automation persistent, combine Python scheduling with cron or systemd. You can configure a cron entry that runs this script at startup, ensuring the scheduler restarts automatically after any reboot. This shows awareness of operational reliability, a huge plus in interviews.
Why interviewers ask this question most often?
This question measures how well you understand automation lifecycles. Interviewers want to see that you can not only schedule but also monitor, alert, and recover jobs. A strong answer proves you think in terms of long-running, self-sustaining systems, exactly what DevOps automation demands.
Which companies ask this question more often?
1. Cloud-native organizations, AWS, GCP, Azure, focus on persistent and monitored automations. 2. SaaS platforms, Atlassian, Freshworks, ServiceNow, value in-code schedulers that scale within containers. 3. System integrators, Accenture, Infosys, TCS, test your ability to automate recurring maintenance tasks. 4. Startups and DevOps consultancies, look for flexible scheduling with recovery awareness.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design interview questions and answers required for your Java or Python interviews, jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
6. How do you list, copy, and move files using Python?
Answer. Good answer. You can use the OS and SHUTL modules to list, copy, and move files in Python. For example, os.lister lists files and SHUTL.copy copies them. Review of the answer. This answer is correct but generic. It doesn't show the practical aspects like error handling, permission issues, or recursive operations, all of which matter in real automation tasks.
Better answer, using OS, pathlib, and SHUTL for reliable file operations.
In real-world automation, I use a combination of OS, pathlib, and SHUTL modules. os.lister helps me iterate through directory contents, pathlib provides object-oriented path manipulation, and SHUTL enables robust file copy and move operations. Together, they make the automation readable, portable, and error-resistant. Review of the answer. This is an excellent answer for a fresher. It introduces modern best practices, pathlib, and demonstrates awareness of real system workflows. However, it can still be improved by addressing how to handle permission errors or verify operations after execution. Here is the code that lists, copies, and moves files using OS, pathlib, and SHUTL. Disclaimer: always test code in a non-production environment. Here is where we import path, a modern and safer way to handle file system paths compared to string concatenation. Here's the command that lists all items in a directory. This is how automation scripts identify files to process. Here's the line that performs the actual copy. SHUTL ensures compatibility across operating systems and retains file metadata. Here is the safety check to ensure the file exists before moving. This prevents runtime errors in automation. Here's the command that moves a file from one directory to another. In automation, this is useful for archiving processed data or logs.
Best answer, handling permission errors and operation verification.
In production automation, permission errors or missing files are common. I handle these using try-except blocks and post-operation verification. For instance, after copying, I confirm the file exists at the destination. This extra validation ensures reliability, which is crucial in pipelines or nightly jobs. Review of the answer. This version is professional. It shows ownership. You're not just running commands but ensuring the automation works safely under all system conditions. Here is the code that safely handles permission errors and verifies successful copy operations. Disclaimer: always test code in a non-production environment. Here is the start of a try-except block, the foundation of safe automation. It captures and handles expected errors cleanly. Here is the verification check. It ensures that the copied file truly exists at the target location before continuing. Here's the permission handler. This prevents script crashes when file system restrictions block access. Here's the safety net for missing files, critical when automating servers that may clean up temporary files. Here's the fallback for unexpected issues, a best practice to always report the root cause instead of failing silently.
Curveball: what if the script needs to handle thousands of files efficiently?
In such cases, I use generators or batch processing to handle files incrementally instead of loading all at once. Python's os.scander parentheses is faster than os.lister parentheses, and combining it with multiprocessing can drastically reduce processing time. Mentioning this shows awareness of performance optimization, something interviewers love.
Why interviewers ask this question most often?
Interviewers use this question to test both technical and operational thinking. File handling is the backbone of many automations, backups, log rotations, data transfers. They want to see if you can manage files safely, efficiently, and predictably under real-world constraints.
Which companies ask this question more often?
1. Service-based companies, Infosys, TCS, Wipro, focus on basic file automation and reliability. 2. Cloud solution firms, AWS, Azure, GCP teams, test OS-level familiarity and safe scripting habits. 3. Fintech and data firms, Stripe, PayPal, check for awareness of safe log rotation and backups. 4. Startups, expect optimization awareness when dealing with high-volume data pipelines.
7. Write a Python script to compress and extract log files automatically.
Answer: good answer. You can use Python's zip file module to compress and extract log files. For example, you can use zipfile.write parentheses to compress and zipfile.extract all parentheses to unzip. Review of the answer: this is factually correct but too basic. It doesn't demonstrate automation awareness, like how logs are dynamically named, or how to handle partial extractions and missing files.
Better answer: automating compression and extraction using Python's zipfile module.
In automation tasks, logs often accumulate daily and take up space. I use Python's zipfile module to compress these logs automatically, reducing disk usage. The same script can later extract these files when needed. This is useful for archiving and managing logs in CI/CD environments. Review of the answer: this shows solid understanding. You're not just compressing files manually but automating daily cleanup and archival processes. Still, you can strengthen it by showing dynamic file naming and error handling. Here is the code that compresses and extracts log files automatically using Python's zipfile module. Disclaimer: always test code in a non-production environment. Here is the import that allows Python to work with zip archives. It handles both compression and extraction. Here is the dynamic archive naming logic. This ensures that every day's logs are stored in a uniquely named zip file like logs_20251104.zip. Here is the block that creates a new zip file in write mode. It ensures safe file closure and resource management. Here's the command that adds each .log file to the zip archive, stripping directory paths for cleaner storage. Here is the extraction step. It unpacks all compressed logs into a temporary directory for review or analysis.
Best answer: adding error handling and log rotation awareness.
In production, I enhance this script with error handling and rotation logic. I check for incomplete or locked logs before compression, and verify zip integrity afterward. For large deployments, I use gzip for single file compression or tar file for multiple nested directories. Review of the answer: this is a mature answer. It shows not just the ability to automate, but also the foresight to ensure that automation does not break under real-world file system conditions. Here is the code that adds error handling and rotation checks to automated log compression. Disclaimer: always test code in a non-production environment. Here is where you configure logging for your automation script. Every compression action or error is recorded for auditing. Here is the core compression step. Zip_deflated reduces file size efficiently while maintaining compatibility. Here's the line that compresses individual log files. It also stores only the file name, not the full path, inside the archive for simplicity. Here is the verification check. It tests the integrity of each file inside the zip. If a corrupted entry is found, it is logged for later review. Here is the safety catch for restricted directories. This prevents the script from crashing if it encounters protected logs.
Curveball, how would you automate this for daily execution and log rotation?
I would combine this script with a cron job, Linux, or task scheduler, Windows. Each day, the cron triggers compression, stores the zip with a timestamp, and deletes logs older than 7 days. Adding an email or Slack alert for any compression failure ensures complete operational reliability. This answer shows end-to-end awareness, from scripting to production readiness.
Why interviewers ask this question most often?
This question checks if candidates understand the full lifecycle of file management automation, from compression to verification and recovery. It distinguishes those who merely know modules from those who understand how automation interacts with system performance and data retention.
Which companies ask this question more often?
1. IT service companies, TCS, Infosys, HCL, focus on practical automation like log rotation and backups. 2. Product-based DevOps teams, AWS, Red Hat, Atlassian, expect awareness of daily operational scripts. 3. Fintech organizations, Paytm, Razorpay, emphasize secure and verified archiving. 4. Cloud monitoring startups, look for operational safety, space optimization, and automation control.
8. How do you rotate log files daily with Python?
Answer: good answer. You can rotate log files by creating a new file each day and deleting old ones manually or using a script. Review of the answer: this is a very basic answer. It shows awareness of the concept but doesn't demonstrate automation. Interviewers want to see how you can implement reliable, scheduled log rotation using Python's built-in tools.
Better answer: using Python's logging module for automatic log rotation.
Python has built-in support for automatic log rotation via the logging.handlers module. The rotating file handler and timed rotating file handler classes handle log rotation based on file size or time. For daily rotation, I use timed rotating file handler. It creates a new log every day and keeps the last few backups automatically. Review of the answer: this version is much stronger. It demonstrates understanding of both built-in modules and their real-world application. But to impress, you should show how to handle retention policies and monitor rotation success. Here is the code that automatically rotates log files daily using Python's timed rotating file handler. Disclaimer: always test code in a non-production environment. Here is the import that enables automatic log rotation. Timed rotating file handler is part of Python's standard library, no external dependency required. Here's the main rotation setup. This line tells Python to create a new log file every midnight and keep the last 7 logs as backups. Older ones are automatically deleted. Here is the formatting step. This makes sure each log entry includes a timestamp, log level, and message for easy debugging. Here's where the handler is attached to the logger. This ensures all future log messages go through the rotation system. Here's the simulation. Writing log entries automatically triggers rotation when the date changes or limits are reached.
Best answer: integrating log rotation with monitoring and retention policies.
In production, I use the same logic but also verify that old logs are archived before deletion. I integrate the rotation handler with cloud storage, like AWS S3, or a local archive directory. This ensures compliance and long-term audit readiness. Additionally, I monitor the size of the latest log file. If rotation fails or logs grow unusually fast, an alert is triggered. This proactive monitoring is key in DevOps environments. Review of the answer: this version connects Python automation to real operational needs, log lifecycle management, compliance, and observability. It's not just code, it's responsible automation. Here is the code that extends log rotation with size checks and retention verification. Disclaimer: always test code in a non-production environment. Here is the same rotation setup as before. This creates 1 log per day and keeps 5 recent backups, providing 1 business week of retention. Here's the file size calculation. This converts bytes to megabytes and checks if the current log file has grown too large. Here's the early warning condition. It detects when logs exceed the safe threshold before midnight and flags it proactively. Here is the verification logic. It lists all rotated logs, which Python names like service.log.November 4, 2025, to confirm retention is working correctly. Here's the reporting statement. It logs the count of retained logs for audit and debugging purposes.
Curveball: what if the server doesn't have permission to create new log files?
In that case, I handle it by adding a fallback. When rotation fails due to permission errors, I redirect logs to an alternate writable path, like /tmp or a backup folder. This ensures the service never loses visibility. This is exactly the kind of proactive awareness interviewers want to see.
Why interviewers ask this question most often?
This question is used to test operational reliability. Logging is at the heart of every production system. Rotation, retention, and recovery define how well your automation behaves under load. A fresher who knows how to automate log rotation already sounds like a mature DevOps engineer.
Which companies ask this question more often?
1. CloudOps and monitoring teams, AWS, Datadog, Splunk, test if you can handle log lifecycle automation. 2. Service companies, TCS, Infosys, Accenture, check if you can manage log retention and cleanup tasks. 3. Product-based firms, Google, Red Hat, Atlassian, value operational awareness and error-proof automation. 4. Startups and SRE roles, expect you to talk about log visibility and recovery strategies.
9. How do you read and modify JSON or YAML configuration files in Python?
Answer: good answer. You can use the JSON module to read and write JSON files, and the PyYAML library for YAML files. Review of the answer: this answer is technically correct but far too short. It doesn't explain how to maintain formatting, preserve comments, or validate configurations, all of which are crucial for automation and deployment pipelines.
Better answer: using JSON and YAML modules for configuration management.
In Python automation, configuration files, like JSON and YAML, are used to store environment settings, API credentials, or deployment parameters. You can load them using json.load parentheses or yaml.safe_load parentheses, modify them in memory, and then write back safely. For example, updating a version number or enabling a new feature flag in a config file can be done dynamically during a CI/CD pipeline run. Review of the answer: this is a practical and structured answer. It shows that you understand reading and writing configs, not just parsing them. However, a top-tier answer should also discuss data validation and preserving structure during rewrites. Here is the code that reads, modifies, and writes back a JSON configuration file safely in Python. Disclaimer: always test code in a non-production environment. Here is where we open the configuration file in read mode. Using a context manager ensures the file is properly closed even if an error occurs. Here's the command that converts JSON data into a Python dictionary, allowing you to modify it like normal Python objects. Here's where the modification happens. Updating configuration keys dynamically lets you automate version bumps or environment toggles. Here's the command that writes the updated configuration back to disk, with indentation for readability and maintainability. Here's the confirmation output: good scripts always communicate successful completion clearly.
Best answer: safely modifying YAML with comment and order preservation.
In production, YAML is preferred because it's more readable for complex configurations. However, a naive rewrite using PyYAML removes comments and reorders keys, a big issue for maintainability. To prevent this, I use ruaml.yaml, a library that preserves comments and key order. It's perfect for DevOps scripts that modify CloudFormation templates or Kubernetes manifests without breaking structure. Review of the answer. This version shows real mastery. It proves you understand not only the syntax but the operational side of automation, which is key in interviews for DevOps roles. Here is the code that modifies a YAML file while preserving comments and key order using ruaml.yaml. Disclaimer: always test code in a non-production environment. Here is the import for ruaml.yaml. This library keeps comments, spacing, and order intact when modifying YAML files. Here's where the YAML file is read into memory. It becomes a nested Python dictionary while maintaining its original structure. Here's the dynamic modification. In real CI/CD workflows, this can adjust deployment replicas based on environment load. Here's the write-back operation. ruaml.yaml ensures that your output looks exactly like the original file, only with your changes applied. Here's the confirmation step, a small but important message to log the completion of automation safely.
Curveball: how would you validate configurations before writing them?
Before writing, I use Python's John schema for JSON and schema validation tools for YAML. This ensures configurations follow strict formats. For example, ensuring keys like API_key or region exist prevents deployment time failures. This mindset, validating before deployment, shows reliability and ownership.
Why interviewers ask this question most often?
Configuration automation is a foundational DevOps skill. This question checks if you understand the difference between plain scripting and safe configuration management. Great answers mention comment preservation, schema validation, and automation integration, for example, CI/CD pipelines.
Which companies ask this question more often?
1. Cloud-native teams, AWS, Google Cloud, Azure, look for knowledge of safe config modification in pipelines. 2. Product firms, Atlassian, HashiCorp, test awareness of YAML handling for infrastructure templates. 3. Service companies, Infosys, Accenture, expect basic read or write knowledge with JSON. 4. SRE or DevOps roles, value schema validation and comment preserving YAML updates.
10. How can you monitor file changes in real time using Python?
Answer: good answer. You can use the Watchdog library in Python to monitor files and directories for changes like creation, modification, or deletion. Review of the answer: this is correct but too superficial. It doesn't explain what an observer is, how events are handled, or how this fits into automation tasks like log tracking or configuration change alerts.
Better answer: using Watchdog's Observer and Event Handler for real-time file monitoring.
The Watchdog library uses an observer pattern to track file changes in real time. It continuously watches a directory and triggers an event when a file is created, modified, or deleted. This is especially useful in automation, for example, monitoring log files, tracking uploads, or reloading configuration dynamically. Review of the answer: this version explains the mechanism clearly and links it to automation use cases. Still, a professional answer should demonstrate custom event handling and show how to integrate notifications or recovery actions. Here is the code that monitors file changes in real time using Python's Watchdog library. Disclaimer: always test code in a non-production environment. Here is the import that initializes a background observer. This object constantly monitors file system events. Here is the custom event handler class. It defines what should happen when files are created, modified, or deleted. Here's the scheduling step. It attaches your handler to the specified directory so it reacts to all file activity inside it. Here is the command that starts the observer thread, allowing the script to continuously track file changes in real time. Here's the cleanup operation. This ensures the observer is safely stopped when the program exits.
Best answer: adding event logging, alerts, and auto-recovery actions.
In production, I enhance this by adding logging and alerting. Whenever a critical file changes, like app.conf or .env, the script logs the event and can trigger a Slack or email alert. If the change breaks something, it can automatically restore a backup version. This bridges the gap between monitoring and incident prevention, a key DevOps trait. Review of the answer. This answer goes beyond simple monitoring to proactive maintenance. It demonstrates real-world thinking, automation that not only detects but also responds intelligently. Here is the code that adds logging and recovery actions to real-time file monitoring. Disclaimer: always test code in a non-production environment. Here's where logging is configured. Every event is time-stamped and stored, making it easy to audit configuration changes later. Here's the filter condition: it ensures only configuration files trigger alerts, avoiding unnecessary noise. Here is the auto-recovery logic: it immediately backs up the modified configuration file so you can restore it if the change causes a failure. Here's where we attach the custom handler to a production-like config directory. Recursive is off for safety, watching only the top-level files. Here's where real-time monitoring begins: the observer keeps running in the background and reacts instantly to file events.
Curveball: how would you ensure the monitoring script restarts automatically after a crash?
I would integrate it with a process manager like systemd or supervisor. That way, if the Python script crashes, it automatically restarts. You can also use AWS Lambda for event-driven monitoring in the cloud. This shows operational maturity, thinking beyond just the code.
Why interviewers ask this question most often?
File monitoring connects programming with system reliability. Interviewers use this question to test if candidates can build automation that reacts to real-world events, not just scripts that run in isolation. Strong answers mention watchdog, event handlers, alerting, and resilience mechanisms.
Which companies ask this question more often?
1. Monitoring and observability platforms: Splunk, Datadog, New Relic. Check if you can react to file system events. 2. CloudOps teams: AWS, Azure, Google Cloud. Focus on automation tied to config file changes. 3. Enterprise DevOps teams: Infosys, Wipro, IBM. Expect integration with alerts and logging systems. 4. Startups: love when freshers mention Watchdog for self-healing automation scripts.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design interview questions and answers required for your Java or Python interviews, jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
11. How do you clean up old temp or log files without deleting active ones in Python?
Answer: good answer. You can use the OS and time modules to check the age of files and delete old ones using os.remove parentheses. Review of the answer: this is a basic and partially correct response. It shows familiarity with file operations but lacks real-world safety measures like excluding active files or using logging to record deletions.
Better answer, using file age checks with OS and time modules.
To safely clean up temporary or log files, I calculate each file's age using os.path.getTime modification time. If a file is older than a threshold, for example, 7 days, I delete it. However, I skip files currently in use or locked. This avoids breaking running processes. Review of the answer. This answer demonstrates safety and control, but it can be improved further by integrating logging and verification before deletion. Here is the code that deletes old temp or log files safely using file age logic in Python. Disclaimer: always test code in a non-production environment. Here's the logic that calculates file age in days by comparing the file's last modified time against the current system time. Here's the condition that checks if a file has aged beyond your defined retention window, for example, 7 days. Here's the safe delete command, removes the file from disk only if it's not currently in use and passes all safety conditions. Here's the console feedback to show which file is being deleted, useful for debugging or DIY runs. Here's the confirmation output, signals that cleanup is done and the script can safely exit.
Best answer, adding logging, file locks, and DIY run mode for production safety.
In production, file cleanup scripts must never delete active or locked files. I use logging for traceability and a DIY run mode to preview which files would be deleted before actually removing them. To avoid race conditions, I use the SUTL library to detect if a file is opened by another process. This ensures your cleanup automation is safe, auditable, and production grade. Review of the answer. This version demonstrates full operational maturity, handling safety, transparency, and verification all at once. Here is the production-grade cleanup script with logging, DIY run mode, and open file detection using SUTL. Disclaimer: always test code in a non-production environment. Here is the safety feature. With DIY run mode enabled, the script logs files that would be deleted without actually deleting them. Great for testing safely. Here's the critical protection. This line checks if the file is currently opened by another process, preventing accidental deletion of active logs. Here's the logging setup. Every action is time-stamped and recorded for post-cleanup verification and audit purposes. Here's where the DIY run feedback is logged, letting you safely review all potential deletions before making real changes. Here's the final log entry, marking the end of the cleanup process, essential for confirming automation completion.
Curveball: what if you're cleaning shared storage with millions of files?
In that case, iterating every file can become slow. I would use os.scandir parentheses instead of os.listdir parentheses for better performance and stream file paths lazily. For massive directories, I might parallelize cleanup with Python's multiprocessing or offload to an AWS Lambda triggered by S3 lifecycle events. These optimizations show scalability thinking, what interviewers love.
Why interviewers ask this question most often?
This question checks whether you understand automation safety, cleaning up resources without harming active processes. Great answers demonstrate discipline, verifying age, locking, and logging. It's a perfect test of whether you can write production-safe scripts, not just quick hacks.
Which companies ask this question more often?
1. Enterprise DevOps teams, IBM, Oracle, Cisco, focus on cleanup safety and compliance. 2. Service-based companies, Infosys, Accenture, Wipro, test automation of temp or log file management. 3. CloudOps teams, AWS, Azure, want awareness of lifecycle and retention automation. 4. Fintech and banking firms, JPMC, Goldman Sachs, expect reliability and zero data loss guarantees.
12. How do you send an HTTP request and process a JSON response in Python?
Answer: good answer. You can use the requests library to send HTTP requests and use response.json parentheses to parse JSON data. Review of the answer: this answer is technically correct but too generic. It doesn't explain HTTP methods, headers, timeouts, or error handling, all essential for real-world automation and DevOps scripts.
Better answer, using requests.get and response.json parentheses safely with error handling.
Python's requests library makes it easy to interact with APIs. You can send GET, POST, PUT, or delete requests. The response can be parsed as JSON using response.json parentheses. Always include error handling and timeouts to avoid hanging automation. Example, you might use this to fetch system metrics from a monitoring API or get deployment status from Jenkins. Review of the answer. This is a structured and practical answer, but it can be elevated by showing retry logic, API key management, and how to handle real-world failures. Here is the code that sends a GET request and parses a JSON response safely using Python's requests library. Disclaimer: always test code in a non-production environment. Here's where the API request is made. The timeout ensures the script doesn't hang if the server is slow or unreachable. Here's the error check. This line raises an exception automatically if the response code indicates failure, like 404 or 500. Here's where the raw API response is parsed into a Python dictionary, allowing you to work with it easily. Here's the output section. It extracts a specific field from the JSON response and displays it clearly. Here's the timeout handler, catches cases where the API doesn't respond within 5 seconds.
Best answer, adding authentication, retries, and response validation.
In production-grade automation, I always include authentication, retries, and data validation. For example, if fetching system metrics from a private API, I'd use an API key in headers, validate the response fields, and add retries to handle network instability. This approach ensures resilience, crucial for CI/CD pipelines or infrastructure monitoring jobs. Review of the answer. This answer reflects DevOps maturity. It covers reliability, security, and structured error handling, traits that distinguish professional automation scripts. Here is the code that sends authenticated API requests with retries and response validation. Disclaimer: always test code in a non-production environment. Here's where you define your authentication header. This ensures secure access to private APIs without hard-coding credentials into URLs. Here's the retry logic. It automatically retries the request up to 3 times if it fails due to temporary server errors or network issues. Here's where we attach the retry configuration to all HTTPS requests in this session, improving resilience across scripts. Here's the validation logic. Ensures expected keys are present before accessing them, preventing runtime errors or partial data usage. Here's the final output, concise and formatted, great for dashboards or automation logs.
Curveball: what if your API rate limit is exceeded or responses are cached?
If rate limits are exceeded, I check the response headers for retry after and sleep accordingly before retrying. To avoid caching issues, I append timestamps or unique query params to the URL. This demonstrates awareness of network behavior and API etiquette, both important for DevOps automation.
Why interviewers ask this question most often?
This question tests your ability to interact with APIs, the backbone of automation and DevOps. Interviewers want to see if you understand not just how to call APIs, but how to handle failures, authentication, and real-world reliability challenges.
Which companies ask this question more often?
1. Cloud service providers, AWS, GCP, Azure, check for automation scripts using API integrations. 2. Monitoring platforms, Datadog, Splunk, New Relic, expect API familiarity for metrics ingestion. 3. Enterprise automation teams, IBM, Oracle, ServiceNow, test secure access and retries. 4. Startups, value practical API handling and lightweight, resilient code.
13. How can you call an API periodically and log metrics in Python?
Answer: good answer. You can use a loop with the requests library and time.sleep parentheses to call an API repeatedly and print or log the results. Review of the answer: this is basic and technically correct, but it lacks production realism. It doesn't handle logging, scheduling precision, or error scenarios, which are critical in automation scripts.
Better answer: using a loop with logging and exception handling.
To call an API periodically, you can use an infinite loop combined with the time.sleep parentheses function. Log each result using Python's logging module instead of print statements. This ensures visibility and traceability for automation tasks. Review of the answer: this answer shows structure and understanding of periodic execution. However, it still lacks advanced controls like dynamic scheduling, performance efficiency, and safe termination handling. Here is the code that calls an API periodically and logs results safely using Python's logging and requests libraries. Disclaimer: always test code in a non-production environment. Here's the logging configuration: every metric is recorded with a timestamp to a log file for easy trend analysis. Here's where the script fetches data from the API with a timeout, preventing hangs or indefinite waiting periods. Here's where the raw JSON response is parsed into a dictionary so specific fields like star counts can be extracted. Here's the metric logging step: instead of printing, data is safely written to a log file, creating a historical record. Here's the delay mechanism: this pauses execution for 1 minute between API calls, making the script a simple periodic poller.
Best answer: using schedule library and dynamic backoff logic.
In production, I use the schedule library instead of manual loops. It provides precise job scheduling and better readability. I also implement dynamic backoff: if the API fails multiple times, the script waits longer before retrying. Each run success or failure is logged separately. This makes the script more reliable, modular, and maintainable. Review of the answer: this approach demonstrates system-level reliability thinking, moving from basic loops to structured scheduling, and handling network issues gracefully. Here is the code that uses the schedule library and dynamic backoff for API polling and logging. Disclaimer: always test code in a non-production environment. Here's the scheduler: it runs the fetch_metrics parentheses function periodically, respecting the dynamic backoff interval. Here's the exponential backoff logic: if the API fails, the next attempt waits longer, preventing rapid retries that could overload the server. Here's the metric logging: captures resource usage from the API and stores it neatly in a rotating log file. Here's the main loop: continuously checks for pending scheduled jobs, keeping the process lightweight and efficient.
Curveball: how would you integrate alerting when the API fails multiple times?
I'd integrate an alerting mechanism. For example, if failures exceed 3 consecutive runs, the script sends a Slack or email notification using smplib or webhooks. This helps identify network or endpoint issues proactively. It's a great sign of operational readiness in DevOps automation.
Why interviewers ask this question most often?
This question checks if you can design automation that runs continuously, handles errors, and remains efficient over time. Interviewers look for structure, logging, and resilience, all hallmarks of a well-designed automation loop.
Which companies ask this question more often?
1. Cloud monitoring providers: Datadog, Splunk, Dynatrace, value API polling for metrics. 2. Enterprise DevOps teams: IBM, Accenture, Capgemini, check if you handle logging and backoff logic. 3. Startups and SaaS companies, like candidates who can implement lightweight monitoring scripts. 4. Fintech companies, want automation that can detect anomalies or failures early.
14. How can you automate login and form submission on a website using Python?
Answer: good answer. You can use the requests library to send login data via post and then access protected pages with the same session. Review of the answer: this answer is correct at a basic level but too shallow. It doesn't mention session management, CSRF tokens, or handling redirects, all crucial in web automation tasks.
Better answer: using Python's requests.session parentheses for persistent logins.
To automate a login process, you can use the requests.session parentheses object, which maintains cookies and session state between multiple requests. This allows you to log in once and then submit forms or access restricted data seamlessly. For example, this technique can be used to automate dashboard data extraction, periodic reports, or testing login APIs. Review of the answer. This answer shows understanding of how web sessions work, but still lacks robustness. We should handle CSRF tokens, headers, and form validation for a truly resilient solution. Here is the code that automates login and form submission using Python's requests.session parentheses. Disclaimer: always test code in a non-production environment. Here's the session creation. It keeps your cookies and login state alive across multiple requests, just like a real browser. Here's the login call. Sends credentials to the server for authentication, establishing a session cookie automatically. Here's a simple check. Confirm successful login by verifying the HTTP status code. Here's the form submission step. Posts form data to another endpoint using the authenticated session. Here's the final output. Lets you verify if the form submission succeeded, HTTP 200 or 201.
Best answer: handling CSRF tokens, headers, and dynamic forms safely.
Many modern websites use CSRF protection or hidden form tokens to prevent unauthorized submissions. To handle that, I first fetch the login page, parse the token using Beautiful Soup, and include it in the post request. I also include custom headers like user agent and refer to mimic a real browser. This ensures the script behaves like a real user and passes all validation. Review of the answer. This version demonstrates advanced understanding, awareness of CSRF, session handling, and browser-like behavior, shows maturity and real-world readiness. Here is the code that handles CSRF tokens and simulates browser headers for secure form automation. Disclaimer: always test code in a non-production environment. Here's where we extract the CSRF token dynamically from the login page, a security measure required for most modern web apps. Here's the header section. These fields mimic real browser requests to prevent the server from rejecting automation scripts. Here's the secure login step. Sends credentials with CSRF protection and browser headers for legitimacy. Here's the success validation. Checks for the presence of known dashboard text to confirm login success. Here's the form submission logic. Posts data to the target form URL while keeping the authenticated session alive.
Curveball: what if the website uses CAPTCHA or JavaScript-based login?
In that case, static automation like requests won't work. I would use Selenium or Playwright to simulate browser behavior and interact with the page elements directly. These tools execute JavaScript and handle dynamic content, ideal for login forms that change in real time.
Why interviewers ask this question most often?
This question tests if you understand real-world web automation challenges. Interviewers want to see that you know how to manage sessions, CSRF tokens, and browser-like headers, not just send simple post requests. Great answers show a blend of web fundamentals and automation discipline.
Which companies ask this question more often?
1. QA automation firms, BrowserStack, TestSigma, test your understanding of form handling. 2. Web scraping and data firms, Diffbot, Import.io, check your knowledge of sessions and CSRF tokens. 3. Product companies, Amazon, Atlassian, Zoho, expect automation for dashboards and APIs. 4. Startups, value lightweight scripts for repetitive web tasks and admin automation.
15. How do you scrape structured data safely and ethically using Python?
Answer: good answer. You can use Beautiful Soup to parse HTML and extract specific tags or data from web pages. Review of the answer. This is the most common fresher response, technically correct but missing awareness about legal, ethical, and technical challenges. It also doesn't show any structure for handling dynamic pages, pagination, or rate limits.
Better answer: parsing HTML with Beautiful Soup and respecting robots.txt.
The Beautiful Soup library allows you to extract data from HTML safely. I always start by checking the website's robots.txt to confirm scraping permissions and then add polite request headers to avoid being blocked. This ensures that automation remains ethical and compliant with web standards. Review of the answer. This answer improves on ethics and structure, but it can still be elevated by including error handling, user agent rotation, and data export mechanisms for real-world reliability. Here is the code that scrapes structured data using Beautiful Soup while respecting website guidelines. Disclaimer: always test code in a non-production environment. Here's the request header: mimics a real browser to avoid being flagged as a bot by web servers. Here's where the HTML content is parsed into a tree structure, making it easy to navigate and extract data from specific tags. Here's the main loop: iterates through all product entries in the page that match the given class. Here's the data extraction step: retrieves the product name and removes unwanted whitespace. Here's the final output: displays the extracted name and price in a clean, structured format.
Best answer: handling pagination, rate limits, and dynamic content.
In real-world automation, scraping one page is not enough. I handle pagination by detecting next links and rate limits using time.sleep parentheses between requests. For dynamically loaded content, via JavaScript, I use Selenium or Playwright to render pages before parsing. I also export the data to CSV or JSON for downstream automation workflows. Review of the answer: this version shows end-to-end automation maturity, data integrity, ethical practices, and scalability for larger datasets. Here is the code that scrapes paginated and dynamic content safely, with rate limiting and CSV export. Disclaimer: always test code in a non-production environment. Here's the pagination loop: iterates through multiple pages sequentially to collect comprehensive data. Here's the data export setup: writes the extracted content into a CSV file for easy analysis later. Here's the rate limiting control: adds a 2-second delay between requests to avoid overwhelming the server. Here's the element extraction logic: ensures clean data retrieval from structured HTML components. Here's the confirmation output: logs progress for debugging and tracking during scraping.
Curveball: what if the website's data is protected or has anti-bot systems?
If scraping violates site terms or triggers protection, I immediately switch to official APIs if available. For pages using JavaScript rendering or CAPTCHA, I would use browser automation tools like Playwright with proper delay and authentication. The ethical key is always: use scraping only for permitted, public data and prefer APIs over HTML parsing.
Why interviewers ask this question most often?
This question tests both your technical and ethical maturity. Many candidates can write Beautiful Soup code, but only a few understand compliance and responsible automation. Great answers balance efficiency, respect for site policies, and reliability.
Which companies ask this question more often?
1. Data aggregation firms, ScrapeI, Diffbot, focus on large-scale web extraction and ethics. 2. Testing or QA platforms, BrowserStack, Teslio, check HTML parsing proficiency. 3. Tech product firms, Google, LinkedIn, Amazon, expect automation that respects security. 4. Startups, love candidates who can build quick, compliant data gathering tools.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design interview questions and answers required for your Java or Python interviews, jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer. System design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
16. How can you send alerts when an API fails continuously using Python?
Answer. Good answer. You can monitor an API by checking its response status using requests and send an alert when it fails multiple times. Review of the answer. This is a fair starting point, but it's too generic. It doesn't explain how to track failure counts, send notifications, or reset alerts intelligently. Real DevOps systems require stateful tracking and automated recovery mechanisms.
Better answer. Tracking consecutive failures and sending basic email alerts.
You can write a script that periodically checks the API response and counts consecutive failures. When the number of failures exceeds a threshold, it sends an email alert using Python smlib. This adds real monitoring logic. It's simple but practical for small-scale DevOps or QA setups. Review of the answer. This is a strong foundation, but it can be improved by introducing retry intervals, state persistence, and integration with messaging services like Slack or AWS SNS for scalable alerting. Here is the code that checks API health and sends an email alert after consecutive failures using Python. Disclaimer: always test code in a non-production environment. This initializes the failure counter at 0 before monitoring begins. This defines how many consecutive failures trigger an alert, in this case, 3. This line sends the API health check request with a timeout to avoid indefinite waits. This increments the failure counter when an exception occurs or a non-200 status is returned. This builds the alert message to notify the DevOps team about repeated API failures. This sends the alert email through the SMTP connection to the recipient list.
Best answer. Using Slack webhooks and persistent state for real-time alerting.
In a more advanced setup, I integrate Python's monitoring logic with Slack or AWS SNS for scalable alert delivery. I also maintain persistent failure state in a local JSON file, so alerts survive restarts and prevent redundant notifications. This adds resilience and production readiness. Review of the answer. This version showcases maturity. It blends practical monitoring with reliability and alert optimization. It's an ideal real-world answer for fresher DevOps interviews. Here is the code that integrates Slack webhooks for API failure alerts with persistent failure state tracking. Disclaimer: always test code in a non-production environment. This defines the file where failure count is stored, ensuring persistence between script runs. This specifies the Slack webhook endpoint for sending alert messages to the team. This condition checks if the API is healthy and resets the failure count if successful. This builds the Slack alert message dynamically using the current failure count. This updates the JSON file with the current failure count, maintaining state between iterations.
Curveball. How would you avoid spamming alerts when the API flaps, fails and recovers quickly?
I'd introduce hysteresis, only trigger alerts after consistent failures and send a recovery alert once stability returns. This prevents noisy notifications and helps DevOps teams focus on real incidents. Additionally, I'd log downtime duration to measure reliability and performance.
Why interviewers ask this question most often?
This question checks your ability to connect automation with observability. Good answers show understanding of alert fatigue, retries, and monitoring design, all critical for real-world DevOps environments.
Which companies ask this question more often?
1. SRE or DevOps organizations, Google, AWS, IBM, test understanding of alerting and reliability. 2. Cloud monitoring companies, Datadog, Splunk, New Relic, value operational awareness. 3. Service-based IT companies, TCS, Infosys, Accenture, focus on scripting alerts for APIs. 4. Startups, prefer lightweight, code-driven observability using Slack or email.
17. How can Python interact with AWS or cloud resources?
Answer. Good answer. Python can interact with AWS using the Boto 3 library, which provides APIs for AWS services like EC2, S3, and Lambda. Review of the answer. This is a common fresher response, correct but surface level. It does not mention authentication, IAM roles, or safe cloud automation practices. A real-world answer must show awareness of both access security and operational workflows.
Better answer, using Boto 3 for programmatic access to AWS resources.
The Boto 3 library allows Python scripts to manage AWS resources programmatically. You can list, start, stop, or create cloud resources directly through the API. It uses IAM credentials for secure access, either via /AWS or credentials, environment variables, or IAM roles when running inside EC2 or Lambda. For example, you can use Boto 3 to list all S3 buckets, check EC2 instance statuses, or automate backups. Review of the answer. This shows solid knowledge of Boto 3 usage and IAM concepts. However, it can be made stronger by connecting it to DevOps automation workflows such as CI/CD or disaster recovery. Here is the code that lists all S3 buckets using Python's Boto 3 library. Disclaimer: always test code in a non-production environment. This line initializes an S3 client using the configured AWS credentials for secure API access. This line makes the API call to list all S3 buckets accessible by the IAM role or user. This loop iterates through the response to display all bucket names in your AWS account.
Best answer, automating AWS operations securely with IAM roles and CI/CD integration.
In production, I use Boto 3 scripts to automate cloud tasks securely within CI/CD pipelines. For example, a Jenkins job can trigger a Python script that automatically scales EC2 instances or rotates access keys. Instead of hard-coding credentials, I attach IAM roles to the instance or container, ensuring least privilege access. This way, Python becomes a reliable bridge between automation tools and cloud infrastructure. Review of the answer. This answer demonstrates complete operational awareness, secure access, automation workflows, and CI/CD integration. It shows readiness for real-world AWS DevOps environments. Here is the code that start-stopped EC2 instances automatically using Boto 3. Disclaimer: always test code in a non-production environment. This filter ensures that only stopped instances are fetched, avoiding unnecessary API calls. This line extracts instance IDs from the nested AWS API response for use in the start command. This command programmatically starts the stopped EC2 instances through AWS APIs.
Curveball: what if the AWS credentials expire or the IAM policy restricts actions?
In that case, I would configure the AWS CLI with temporary STS tokens or use role-based authentication to refresh credentials automatically. I also include permission checks, like using IAM:simulate principal policy, before running critical automation tasks. This ensures the script never fails unexpectedly due to missing privileges.
Why interviewers ask this question most often?
This question evaluates if you can bridge Python scripting with real-world cloud automation. Interviewers look for candidates who understand security, IAM, scalability, and hands-on Boto 3 experience, all essential for DevOps engineers working with AWS.
Which companies ask this question more often?
1. AWS partners, Capgemini, Deloitte, Accenture, test basic Boto 3 usage and IAM awareness. 2. Cloud-native startups, check automation and infrastructure scripting skills. 3. Product companies, Amazon, Salesforce, Atlassian, focus on integrating cloud operations into CI/CD pipelines. 4. Managed service providers, value secure, reusable Bodo 3 automation scripts.
18. How can you trigger a Jenkins build remotely via Python?
Answer. Good answer. You can trigger Jenkins builds remotely using the REST API by sending an HTTP POST request to the Jenkins jobs build URL. Review of the answer. This is technically correct but incomplete. It does not mention authentication, CSRF protection, or how this fits into CI/CD automation. A strong answer should demonstrate both secure connection handling and contextual awareness of where this automation fits in a DevOps pipeline.
Better answer. Triggering Jenkins jobs securely using the REST API and API tokens.
To trigger Jenkins builds programmatically, I use Python's requests library. Jenkins exposes a REST endpoint that accepts POST requests for builds. Instead of using a username-password pair, I use an API token for authentication. This is safer and recommended for CI/CD integrations. In many DevOps workflows, this script runs after code merges to trigger test or deploy pipelines automatically. Review of the answer. This is a solid and realistic approach, but it can be made stronger by showing how to handle CSRF protection, crumbs, and by providing actionable error handling and build monitoring logic. Here is the code that triggers a Jenkins build remotely using Python's requests module and API token authentication. Disclaimer: always test code in a non-production environment. This defines the endpoint for the Jenkins job you want to trigger. Every job has its own build URL. This line sends the POST request to Jenkins with authentication credentials to trigger the build. This checks if Jenkins accepted the request and successfully queued the build. This provides feedback confirming that the build request was processed.
Best answer. Handling CSRF protection and verifying build status.
In production, Jenkins might require a CSRF crumb for every request. I handle this by fetching a crumb from Jenkins first and passing it along in headers during the build trigger. Additionally, I check the queue or build status endpoint to confirm if the job is running or has completed successfully. This ensures robust automation and avoids silent failures in your pipeline. Review of the answer. This demonstrates complete operational understanding, security, CSRF, verification, status checks, and integration logic for CI/CD. It is a production-ready fresher-level answer that shows maturity. Here is the code that handles Jenkins CSRF protection and checks build status programmatically using Python. Disclaimer: always test code in a non-production environment. This line retrieves a CSRF crumb token from Jenkins, which must be sent with all POST requests for security. This step formats the crumb into a header field that Jenkins validates for every authenticated request. This sends the authenticated and crumb-protected POST request to trigger the build safely. This defines the API endpoint used to query the most recent build and retrieve its details. This prints the build result, for example, success, failure, or in progress, to confirm completion.
Curveball. What if Jenkins is behind a corporate proxy or uses self-signed certificates?
If Jenkins uses self-signed certificates, I set verify equals false in requests temporarily or install the certificate chain locally. For proxy networks, I configure the HTTP_proxy and HTTPS_proxy environment variables before running the script. These tweaks ensure automation runs smoothly even in restricted environments.
Why interviewers ask this question most often?
This question checks whether you can automate CI/CD pipeline interactions securely and intelligently. Interviewers expect awareness of REST API usage, authentication safety, and Jenkins CSRF handling. It also tests your ability to connect Python scripts with real automation workflows.
Which companies ask this question more often? 1.
Product firms, Google, Atlassian, ServiceNow, test CI/CD integration awareness. 2. DevOps-driven teams, AWS, IBM, Red Hat, evaluate REST API and Jenkins orchestration skills. 3. IT services firms, Infosys, Wipro, Accenture, focus on practical automation tasks. 4. Cloud-native startups, appreciate code-driven, secure, and flexible pipeline triggers.
19. How can you automate infrastructure validation before deployment?
Answer. Good answer. You can automate infrastructure validation by checking system configurations and resource availability using Python scripts before deploying new builds. Review of the answer. This response is fine but vague. It does not specify how validation is done or which tools or libraries are used. Stronger answers should demonstrate pre-deployment checks that ensure infrastructure readiness, verifying instances, databases, or configurations before code rollout.
Better answer, validating infrastructure health and configurations using Python and Boto 3.
Before deployment, I use Python scripts to verify whether AWS resources like EC2, S3, or RDS are in a healthy state. Using Boto 3, we can confirm that required services exist, have correct tags, and are reachable. This prevents deployment failures due to missing infrastructure components. For example, I validate that load balancers are active, database connections work, and storage buckets are accessible. Review of the answer. This answer demonstrates technical understanding and readiness checks but can be improved by integrating automated responses, for example, halting CI/CD pipelines if validation fails. Here is the code that validates EC2 and RDS instance health before deployment using Boto 3. Disclaimer: always test code in a non-production environment. This initializes the EC2 client so the script can query compute instance health and status. This initializes the RDS client for checking the database service state and readiness. This API call retrieves the current status of all EC2 instances, including stopped or pending ones. This validation ensures every EC2 instance required for deployment is running before rollout. This line fetches the list of all RDS database instances for validation. This prints a confirmation for healthy RDS instances, helping the DevOps team quickly identify readiness.
Best answer, integrating validation into CI/CD pipelines with automated fail-safe mechanisms.
In CI/CD environments, I integrate Python validation scripts directly into Jenkins or GitHub Actions. The script runs as a pre-deployment step. If any resource is unavailable, it stops the pipeline and alerts the DevOps team via Slack or email. This approach ensures zero blind deployments and maintains infrastructure integrity. Review of the answer. This answer demonstrates full DevOps maturity. You're thinking not just about writing validation scripts, but embedding them within automated workflows that prevent downstream failures. Here is the code that integrates infrastructure validation with Slack alerts in a CI/CD pipeline. Disclaimer: always test code in a non-production environment. This defines the Slack webhook URL used for sending alert messages when validation fails. This initializes a list that will store all instance IDs that fail health checks. This line sends an alert to Slack notifying the DevOps team of pre-deployment validation failure. This exits the pipeline immediately if infrastructure validation fails, preventing risky deployments. This prints a success message confirming that all validation checks have passed.
Curveball: what if the validation step fails due to AWS throttling or API timeouts?
I would implement exponential backoff and retries using Python's botocore.config to handle throttling gracefully. Additionally, I would cache previous healthy states so transient API failures do not block the pipeline unnecessarily. This prevents false negatives during deployments.
Why interviewers ask this question most often?
This question tests if you can combine scripting, infrastructure knowledge, and DevOps workflows. Employers want candidates who can ensure deployment safety through automation. It reflects foresight and responsibility, even at a fresher level.
Which companies ask this question more often?
1. AWS and Cloud Ops companies assess Boto 3 fluency and validation scripting. 2. Service-based IT firms, Accenture, Infosys, Wipro, test pre-deployment checklist automation. 3. Product-based DevOps teams, Google Cloud, Atlassian, focus on CI/CD pipeline integration. 4. Startups, value preventive automation that minimizes production risk.
20. Explain how Python can be used to parse and validate CI/CD logs.
Answer. Good answer. You can use Python to read log files line by line and check for specific error keywords or patterns using string matching or regular expressions. Review of the answer. This is technically correct but too simplistic. It does not mention how to handle multi-line logs, timestamps, or structured log formats. A stronger answer would include Python's built-in logging and regex capabilities, along with a strategy to extract useful insights from raw CI/CD logs.
Better answer, using regex and Python's logging for automated log analysis.
Python is excellent for parsing CI/CD logs because it can efficiently process text, JSON, or structured output. I usually open the log file and use the re module to detect error patterns like error or failed. For example, when Jenkins or GitHub Actions produce long build logs, I use Python scripts to summarize failed test cases, missing dependencies, or deployment issues. Review of the answer. This shows structured thinking. You are using regex for filtering and pattern recognition. But you can improve it by demonstrating how to summarize results or generate reports automatically. Here is the code that parses Jenkins log files and highlights build errors using regex. Disclaimer: always test code in a non-production environment. This line safely opens the build log file with a context manager so it closes automatically after reading. This uses regex to search for key failure indicators like error, fail, or exception within each log line. This collects matching lines along with their line numbers to make the error summary more informative. This prints each error clearly, helping engineers quickly locate where a build failed.
Best answer, building automated log validators with alerts and JSON reports.
In production CI/CD environments, I take this further by parsing structured logs, like JSON, and creating validation reports. For example, I extract build durations, failed test modules, and error frequency, then send the results to a dashboard or Slack channel for visibility. This transforms log analysis into proactive monitoring, not just error detection. Review of the answer. This demonstrates an evolution from manual parsing to intelligent automation, a hallmark of engineers who connect scripting with observability. Here is the code that generates structured JSON error reports from CI/CD logs and sends alerts to Slack. Disclaimer: always test code in a non-production environment. This regex pattern captures both the error type and its message from each log line. This step converts each log error into a dictionary entry so it can be exported or processed later. This writes all captured errors into a structured JSON file for reporting and auditing. This sends a notification to Slack, giving the DevOps team real-time awareness of build failures. This prints a clear success message when no errors are detected, confirming log validation passed.
Curveball: what if the CI/CD log is massive or streamed live?
For large or streaming logs, I would use Python generators, Yield, or libraries like Watchdog to monitor files in real time. This approach prevents loading the entire file into memory and supports continuous log streaming, ideal for Jenkins, CircleCI, or Kubernetes environments.
Why interviewers ask this question most often?
This question evaluates your understanding of automation, debugging, and data extraction. It checks whether you can transform raw logs into actionable insights, a vital skill for DevOps and site reliability engineers.
Which companies ask this question more often?
1. Product-based tech firms, Google, Atlassian, Netflix, emphasize automation visibility and log intelligence. 2. Cloud service providers, AWS, Azure, GCP, value real-time log processing for pipelines. 3. Service-based companies, TCS, Infosys, Cognizant, test file parsing and reporting automation. 4. Startups, focus on proactive log alerts and minimal downtime monitoring.
21. How can you automate a rollback process using Python and Git?
Answer: good answer. You can automate a rollback process by using Git commands and Python scripts to revert to a previous commit when a deployment fails. Review of the answer: this is correct but basic. It doesn't explain how the rollback integrates into CI/CD or handles partial rollbacks. A more complete answer would involve validating the target version, automating rollback commands, and logging the entire process.
Better answer: using Python's subprocess module to revert Git commits.
In simple automation setups, Python can call Git commands using the subprocess module. The script can fetch the last successful commit hash from logs or CI metadata, revert the repository, and push the rollback to the remote branch. This ensures quick recovery when deployment validation fails. Review of the answer: this answer introduces practical automation through Git subprocess calls. It can be improved further by validating that the target commit builds correctly before redeploying. Here is the code that performs a simple Git rollback using Python subprocess module. Disclaimer: always test code in a non-production environment. This specifies the Git commit hash to which the codebase should revert. This executes a hard reset in Git, reverting the working directory and staging area to the specified commit. This force pushes the rollback to the remote repository, ensuring all environments reflect the same state. This logs a success message so the pipeline can confirm that the rollback completed without errors.
Best answer: automating conditional rollbacks with verification and notifications.
In production CI/CD, I integrate rollback logic into Jenkins or GitHub Actions using Python. The script first verifies whether the last deployment failed using build logs or API status codes. If failure is confirmed, it triggers a rollback by reverting the repository, redeploying the stable build, and notifying the DevOps team via Slack. This ensures rollback is not random, it happens only after validation, preserving stability and audit traceability. Review of the answer: this version demonstrates maturity. It is not just running a Git command, but coordinating rollback with validation, notifications, and pipeline safety checks. Here is the code that performs conditional rollback with Slack notification and build verification. Disclaimer: always test code in a non-production environment. This fetches the build result from your CI system to confirm if the latest deployment failed. This conditional check ensures that rollback runs only if the build actually failed. This command performs the actual rollback operation in Git. This sends a Slack alert to the DevOps team indicating that rollback has been triggered and completed. This prints a clean confirmation message when rollback is skipped because the build passed.
Curveball: what if the rollback commit also contains configuration mismatches or schema changes?
I would integrate prechecks to verify compatibility, for instance, confirming database schema version tags match before executing the rollback. If configuration drift is detected, the script can abort rollback or trigger a partial restoration for only code, not data. This demonstrates operational judgment rather than blind automation.
Why interviewers ask this question most often?
This question reveals whether you understand automation as more than scripting. It is about controlled recovery and safety. Interviewers assess your ability to blend Python logic, Git operations, and DevOps reliability thinking.
Which companies ask this question more often?
1. Product-based DevOps firms: GitHub, Atlassian, GitLab, Test Version Control Automation Awareness. 2. Cloud-native companies: AWS, GCP, DigitalOcean, Value Rollback and Recovery Design Thinking. 3. Enterprise CI/CD users: Infosys, TCS, Capgemini, look for safe Git automation practices. 4. Startups prefer Python-driven, lightweight rollback workflows with alert integration.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked and system design interview questions and answers. Required for your Java or Python interviews: jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
22. How can you automate post-deployment verification using Python?
Answer: good answer. After deployment, you can write a Python script to verify that services or endpoints are reachable and responding correctly. Review of the answer: this answer is valid but incomplete. It doesn't mention verifying logs, APIs, or application health checks in a structured way. A better answer would include multi-step verification, checking API responses, database connectivity, and configuration consistency.
Better answer: using Python requests and system checks for basic post-deployment validation.
A Python script can confirm that key endpoints, APIs, or services are working after deployment. Using modules like requests and subprocess, you can verify both HTTP responses and system-level services. For example, after deploying a web app, I check if the home page returns a 200 OK status and that the database connection works. These lightweight checks can be part of the CI/CD job's final verification stage. Review of the answer: this answer demonstrates structured thinking and real-world verification logic. However, it can be enhanced by adding monitoring feedback or alert integration. Here is the code that performs basic API and service health checks after deployment. Disclaimer: always test code in a non-production environment. This sends a health check request to your application endpoint with a timeout to ensure responsiveness. This confirms whether the deployed application is returning a healthy HTTP response. This runs a system command to verify if Nginx, or any critical service, is currently active. This interprets the subprocess output to confirm the service status and prints an alert if inactive.
Best answer: integrating automated verification with monitoring and Slack alerts.
In production, I extend post-deployment verification to include multiple checks, API responses, database health, and log scanning. The Python script aggregates all these results and sends a summary report to Slack. This allows DevOps engineers to verify deployment success instantly without manually checking each system. It also serves as a lightweight post-deployment monitoring layer. Review of the answer: this is a production-quality answer that demonstrates proactive validation, observability, and communication, exactly what interviewers expect from automation engineers. Here is the code that performs automated post-deployment checks and sends results to Slack. Disclaimer: always test code in a non-production environment. This performs an HTTP health check to ensure the deployed API is online and responsive. This scans the application log file for any critical errors after deployment. This aggregates all verification results into a formatted message for Slack. This sends the deployment verification summary to the DevOps Slack channel. This prints a local confirmation message for pipeline logs or CLI execution.
Curveball: what if some services take longer to start after deployment?
In that case, I'd implement a retry mechanism with exponential backoff. The script can recheck health endpoints every few seconds up to a maximum wait period. This prevents false alerts when systems need a few moments to stabilize after deployment.
Why interviewers ask this question most often?
This question checks whether you understand the final phase of DevOps automation, post-deployment validation. It assesses your ability to confirm successful rollouts and proactively detect failures before users are impacted.
Which companies ask this question more often?
1. Cloud-based DevOps teams, AWS, Azure, GCP, test monitoring and validation automation skills. 2. Service-based companies, Accenture, Infosys, TCS, focus on verification scripting after deployments. 3. Product-based firms, Netflix, Atlassian, Google, value proactive validation for zero downtime rollouts. 4. Startups, want lightweight, code-driven post-deployment checks integrated with Slack or API alerts.
23. How can you automate configuration drift detection in servers using Python?
Answer. Good answer. You can detect configuration drift by comparing current server configurations with a baseline file using Python. Review of the answer. This is correct at a basic level, but it lacks depth. It doesn't explain what a baseline is, how to collect live configuration data, or how to handle multiple servers. A stronger answer shows awareness of collecting configurations dynamically and validating them against stored baselines.
Better answer. Comparing current configurations against baselines using Python and JSON.
Configuration drift occurs when production systems diverge from their intended configuration state. I use Python to fetch live configurations, such as service status, package versions, or environment variables, and compare them against a stored baseline in JSON or YAML. For example, by running commands like uname, systemctl, or cat/etc. or config, I can capture the current state and detect any differences automatically. Review of the answer. This answer adds real context, dynamic retrieval, structured comparison, and baseline management, key parts of any configuration audit. Here is the code that compares live server configurations against a baseline JSON file. Disclaimer: always test code in a non-production environment. This loads the reference configuration baseline stored as a JSON file. This retrieves the kernel version of the current server dynamically. This checks if the Nginx service is active, a key runtime configuration parameter. This compares each current configuration value against the baseline and prints a warning if they differ. This logs a success message for configurations that are consistent with the baseline.
Best answer. Centralized drift detection with baseline repositories and Slack alerts.
In production environments, I extend this logic to multiple servers using SSH or AWS Boto 3. Each system sends its current configuration snapshot to a central location. The Python script compares all snapshots against an approved baseline repository. If drift is found, it creates a detailed report and sends alerts to Slack or a monitoring dashboard. This turns drift detection into a scheduled audit system, preventing security gaps and compliance issues. Review of the answer. This shows maturity and scalability. You understand both the technical and operational layers of maintaining infrastructure integrity. Here is the code that performs multi-server configuration drift detection with alert integration. Disclaimer: always test code in a non-production environment. This initializes an SSH client that allows secure command execution on remote servers. This retrieves live configuration data from each remote host via SSH. This loops through baseline values and compares them against live data for each server. This sends drift alerts to a Slack channel so the DevOps team can act immediately. This prints a clean summary if no configuration drift is detected across servers.
Curveball: what if the baseline itself is outdated?
I would version control baselines using Git or store them in S3 with timestamps. Each time configuration changes are approved, the baseline is updated and tagged. This ensures that drift detection compares against a valid, versioned baseline, not stale data.
Why interviewers ask this question most often?
This question tests your ability to connect automation with infrastructure compliance. Interviewers look for understanding of how Python can maintain consistency across environments and prevent misconfiguration or drift.
Which companies ask this question more often?
1. Cloud and infra teams, AWS, Azure, GCP, test environment audit scripting. 2. Enterprise DevOps, IBM, Oracle, Capgemini, check compliance automation logic. 3. Product firms, Red Hat, Atlassian, assess configuration integrity awareness. 4. Startups, look for lightweight, script-based consistency monitoring approaches.
24. How can you automate drift remediation, fixing configuration mismatches automatically using Python?
Answer. Good answer. You can fix configuration drift by identifying mismatched settings and running corrective commands through Python scripts. Review of the answer. This is directionally correct, but vague. It doesn't explain how the script decides what to fix or how it ensures safety before applying changes. A stronger answer needs clear validation, controlled execution, and logging.
Better answer. Automating remediation for configuration drift with Python and system commands.
Python can automatically fix drift by comparing live configurations to a baseline and applying corrective actions. For example, if a service is stopped but should be active, the script restarts it. If a configuration file has changed, the script restores it from a backup or template. Using subprocess or paramiko, we can execute safe shell commands across servers to bring systems back into compliance. Review of the answer. This adds actionable automation logic, detecting and correcting differences. But it can be made even better by adding logging, approvals, and rollback safety. Here is the code that automatically fixes simple configuration drift by restarting services and restoring files. Disclaimer: always test code in a non-production environment. This checks whether the target service is running as expected. This restarts the service automatically when drift is detected. This defines the trusted baseline configuration file used for restoration. This replaces the modified or corrupted configuration file with the baseline copy. This reloads the service to apply the corrected configuration safely without downtime.
Best answer. Centralized drift remediation with remote execution and approval workflow.
In production-grade setups, I design Python-based drift remediation that works across multiple servers. The script detects drift, logs every mismatch, and requests human approval or executes fixes automatically if flagged as safe. It also verifies post-fix results and reports to Slack. This ensures infrastructure remains compliant without blind automation, achieving the right balance of safety and autonomy. Review of the answer. This demonstrates operational maturity. You're not just automating commands, you're automating decision-making and ensuring observability. Here is the code that performs centralized drift remediation with verification and Slack notifications. Disclaimer: always test code in a non-production environment. This creates a secure SSH session for executing commands remotely across multiple servers. This checks the service state on each remote host. This identifies when the current state differs from the expected baseline. This runs the corrective action to bring the system back into compliance. This sends an alert to Slack, notifying that a drift was found and remediated.
Curveball: what if automatic remediation introduces new issues or downtime?
In such cases, I recommend implementing a safe remediation mode, where fixes are applied in a staging environment first. Once verified, the same corrections are promoted to production. You can also implement a rollback option that reverts changes if the post-fix health check fails.
Why interviewers ask this question most often?
This question tests whether candidates can think beyond detection, towards self-healing automation. Interviewers look for your ability to automate controlled recovery, log results, and prevent repetitive manual intervention.
Which companies ask this question more often?
1. Enterprise DevOps, AWS, IBM, Microsoft, assess safe automation capabilities. 2. CloudOps and SRE teams, Google, Netflix, Atlassian, value self-healing workflows. 3. Service-based firms, Infosys, TCS, Accenture, focus on system drift prevention. 4. Startups, seek lightweight remediation scripts for smaller infra footprints.
25. How can you automate log cleanup and archival in production environments using Python?
Answer. Good answer. You can automate log cleanup by using Python to delete old log files from servers based on their age. Review of the answer. This is a common fresher response. It's partially correct, but it misses two key aspects, safe deletion and long-term storage. A strong answer involves both, automatically cleaning old logs while archiving critical ones for compliance.
Better answer, cleaning old logs safely using file age and archival policies.
In production, log cleanup must be done carefully to avoid losing useful debugging or audit data. I use Python to scan log directories, calculate file ages, and remove only files older than a defined threshold, like 30 days. Important logs are archived before deletion. This ensures disk space efficiency while maintaining operational visibility. Review of the answer. This adds structure and risk awareness. You're now balancing cleanup with retention, a key production skill. Here is the code that deletes old log files older than 30 days using Python's OS and time modules. Disclaimer: always test code in a non-production environment. This defines the directory where your application logs are stored. This fetches the last modified timestamp of each log file. This calculates how old the log file is, converting seconds to days. This checks whether the file exceeds your retention threshold. This safely removes files that are older than the defined limit.
Best answer, automating log archival and cleanup with compression and cloud backup.
In real-world DevOps setups, I extend log cleanup scripts to first compress and archive logs to S3 or another storage bucket before deletion. This keeps historical logs accessible for audits or root cause analysis while optimizing storage. The script can also run as a scheduled cron job or CI/CD post-deployment step. Review of the answer. This is production-grade automation, efficient, auditable, and safe. It shows that you think about both system hygiene and compliance retention. Here is the code that compresses, uploads, and removes old log files automatically using Boto 3 and gzip. Disclaimer: always test code in a non-production environment. This compresses the old log file to reduce its size before uploading. This uploads the compressed log file to your S3 archive bucket for long-term storage. This removes the uncompressed log file after archiving it successfully. This cleans up temporary compressed files to maintain a tidy environment. This provides clear runtime feedback for audit and monitoring logs.
Curveball: what if some logs are actively written to while cleanup is running?
In that case, I use file locking or exclude the currently active log file, for example, app.log, from cleanup. I might also implement timestamp-based rotation where a new log file is created daily and the old one is closed automatically before cleanup. This avoids corrupting active files.
Why interviewers ask this question most often?
This question checks whether you understand operational hygiene, freeing disk space safely while maintaining audit trails. It tests your ability to combine Python scripting, file handling, and cloud integration in a production-safe way.
Which companies ask this question more often?
1. CloudOps teams, AWS, Azure, GCP, check storage automation logic. 2. Enterprise DevOps, IBM, Oracle, Dell, value safe cleanup and compliance retention. 3. Service-based firms, TCS, Infosys, Cognizant, test real-world system maintenance scripts. 4. Startups, look for efficient log archival and cost optimization ideas.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem solving, generally most asked and system design interview questions and answers. Required for your Java or Python interviews: jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
26. How can you automate unit testing with Python and PyTest?
Answer: good answer. You can automate unit testing in Python using the PyTest framework, which helps test functions automatically. Review of the answer: this is correct but incomplete. It doesn't explain how PyTest discovers tests, how to structure files, or how automation integrates with CI/CD. A strong answer should mention test organization, assertions, and how PyTest fits into continuous testing pipelines.
Better answer: using PyTest to write and run automated unit tests.
PyTest is a simple yet powerful testing framework for Python. You create test functions prefixed with test underscore, and PyTest automatically discovers and runs them. You can use Python's built-in assert statements to verify expected outputs. PyTest can generate clean reports and can be integrated with Jenkins or GitHub Actions for automatic validation after every commit. Review of the answer: this answer explains the discovery mechanism and assertion logic clearly, a solid foundation for entry-level automation engineers. This code example demonstrates a basic PyTest unit test for arithmetic functions. Disclaimer: always test code in a non-production environment. This is the source file that contains the arithmetic functions we want to test. This is the test file. PyTest automatically detects files starting with test underscore. This is a test function. PyTest recognizes any function beginning with test underscore as a test case. This line verifies that add parentheses returns the correct result. If incorrect, PyTest reports a failure. This line indicates how to run the test suite from the terminal to execute all detected test cases.
Best answer: automating test execution and reporting with PyTest in CI/CD pipelines.
In real-world DevOps environments, PyTest is integrated into CI/CD pipelines to validate every build automatically. The framework can produce HTML or JUnit XML reports, which can then be parsed by Jenkins, GitHub Actions, or GitLab CI. You can also categorize tests using PyTest markers, such as smoke, regression, or API, and run them selectively using command line options. Review of the answer: this demonstrates complete automation thinking, local validation extended into continuous testing pipelines. This Jenkins file demonstrates how PyTest integrates into a CI/CD pipeline for automated test runs. Disclaimer: always test code in a non-production environment. This command ensures all dependencies, including PyTest, are installed before executing any test stage. This code line runs PyTest in quiet mode, stops at the first failure, and exports the test summary as an XML report for Jenkins to consume. This Jenkins directive imports the PyTest results into the Jenkins dashboard for visualization and tracking.
Curveball: what if some tests fail intermittently or depend on external APIs?
In that case, this test automation should isolate dependencies using mocks and fixtures. Libraries like unitest.mock or pytest.mock can simulate external API responses, ensuring deterministic results. For flaky tests, pytest's rerun mechanism can reattempt failed tests automatically to confirm consistent behavior.
Why interviewers ask this question most often?
Interviewers use this question to test if candidates understand structured test automation, writing, executing, and integrating tests into CI/CD systems. The goal is to confirm awareness of both development correctness and operational validation.
Which companies ask this question more often?
1. Product-based firms, Google, Atlassian, Microsoft, emphasize pytest usage in CI/CD pipelines. 2. Service-based companies, Infosys, Wipro, TCS, check foundational understanding of Python testing frameworks. 3. Cloud-native startups, look for test automation tied to deployment processes. 4. QA-focused teams, evaluate your ability to isolate logic and mock external dependencies.
27. How can you automate API testing using Python and pytest?
Answer. Good answer. You can use Python's requests module to send HTTP requests and pytest to verify the responses automatically. Review of the answer. This answer is fine but very basic. It doesn't mention JSON parsing, response validation, or reusable test structures. A strong answer includes assertions for response codes, data, and schema, and integrates directly into CI/CD pipelines for continuous validation.
Better answer, writing API test cases with pytest and the requests module.
In API automation, pytest provides the testing framework, while the requests module handles HTTP communication. Each API endpoint can be tested for response code, data correctness, and response time. The tests can be grouped, parameterized, and executed automatically using pytest. This makes it simple to validate REST APIs after every deployment. Review of the answer. This version correctly connects the test logic, validation, and structure, suitable for freshers beginning in DevOps and QA automation. This code snippet demonstrates a basic pytest-based API test using Python's requests library. Disclaimer: always test code in a non-production environment. This variable defines the base URL for the test APIs. Using a constant ensures consistency across multiple test cases. This code line sends a GET request to the post's endpoint and captures the HTTP response object for validation. This assertion verifies that the API returned a success status code. A failure here indicates a broken endpoint or misconfiguration. This assertion ensures the response body is a JSON list, validating the structure of returned data. This code snippet checks a specific field inside the JSON response to confirm that the correct resource is returned.
Best answer, automating full API suites with parameterization and CI/CD integration.
In advanced API testing, pytest's parameterization feature allows validating multiple endpoints or datasets in a single run. For CI/CD, I integrate pytest with Jenkins or GitHub Actions, so tests run automatically after deployment and generate structured reports. This approach scales from single API calls to hundreds of endpoints, ensuring both correctness and reliability. Review of the answer. This answer reflects production-level maturity, reusability, scalability, and automation awareness, all critical for DevOps automation engineers. This code snippet demonstrates parameterized API tests and CI/CD compatibility. Disclaimer: always test code in a non-production environment. This line applies pytest parameterization. It defines multiple endpoint and expected type pairs so the same test function validates each endpoint automatically. This line constructs the full URL dynamically and sends the GET request to the API endpoint. This assertion confirms that the API responded successfully with a standard HTTP 200 status. This assertion validates that the response data structure is correct, ensuring consistency across API endpoints.
Curveball: what if the API requires authentication or rate limits requests?
In that case, the test suite should include authentication headers or tokens in the requests. For example, PyTest fixtures can inject credentials securely. To handle rate limits, the test code should include retry logic using exponential backoff, ensuring the tests remain stable without overwhelming the server.
Why interviewers ask this question most often?
Interviewers use this question to gauge whether you can extend basic scripting into real-world quality assurance. They want to see familiarity with the requests library, assertions, and pipeline integration, all core DevOps automation capabilities.
Which companies ask this question more often?
1. Product-based firms, Atlassian, ServiceNow, Salesforce, focus on API testing integration and reliability. 2. Service-based firms, Infosys, TCS, Cognizant, evaluate automation scripting for validation flows. 3. Cloud-native startups, test ability to write lightweight, parameterized API tests. 4. DevOps-centric teams, AWS, Red Hat, Google, check CI/CD compatibility and response validation awareness.
28. How can you generate synthetic test data automatically using Python?
Answer: good answer. You can use Python's random module to generate fake numbers or names for testing purposes. Review of the answer: this is a correct but very basic response. It lacks structure, realism, and awareness of the Faker library, the industry standard tool for generating synthetic yet meaningful test data.
Better answer: using the Faker library for realistic data generation.
The Faker library in Python is designed to create fake but realistic data for testing, like names, emails, IPS addresses, or even credit card numbers. This helps simulate production-like environments safely, without using real customer data. It's widely used in test automation, API mocks, and CI/CD pipelines to seed databases or generate payloads for regression testing. Review of the answer: this version demonstrates clear tool awareness and practical understanding, connecting Python utilities with real QA and DevOps workflows. This code snippet demonstrates how to generate realistic fake data using the Faker library. Disclaimer: always test code in a non-production environment. This line creates a Faker object. This object is used to generate realistic synthetic data like names, emails, and addresses. This line calls a Faker method to produce a human-like name. These values mimic natural names but are fully synthetic and safe for testing. This is where each test user record is constructed. The dictionary includes a random numeric ID for uniqueness and Faker-generated profile information to simulate real user data. This loop prints each generated record, allowing you to preview and verify that the synthetic data looks realistic before using it in automated tests.
Best answer: automating test data generation for CI/CD and database seeding.
In production-ready environments, I combine Faker with automation scripts to continuously populate staging databases or mock APIs. These scripts generate fresh test data during every CI/CD run, ensuring no two test cycles use stale values. For example, you can export Faker-generated data into JSON or CSV files and feed them directly into your test pipelines. Review of the answer: this answer ties the concept to real-world DevOps workflows, continuous data freshness, reproducibility, and test environment realism. This code snippet shows how to generate synthetic data at scale and export it to a JSON file for automation pipelines. Disclaimer: always test code in a non-production environment. This line begins constructing each synthetic user record. Each field inside the dictionary uses Faker-generated data to simulate realistic user profiles. This generates a unique ID for each user in a UUID format, which closely resembles real-world system-generated identifiers. This function generates a realistic sign-up date within the specified time range, helping mimic real system activity timelines. This line serializes and writes the synthetic dataset into a JSON file, formatted with indentation for readability and compatibility with automation tools. This message provides a clear confirmation that data generation is complete and the output file has been successfully created.
Curveball: what if your fake data needs to follow strict rules or match specific formats?
In that case, you can subclass Faker's provider to define custom data generation logic, for example, enforcing a specific phone number pattern or domain name. You can also seed Faker's random generator with faker.seed parentheses to ensure reproducible results across runs, perfect for debugging or CI/CD consistency.
Why interviewers ask this question most often?
This question helps interviewers assess your creativity and practical automation skills. Generating test data programmatically shows you understand test reliability, data variety, and privacy, all crucial in QA, DevOps, and data validation roles.
Which companies ask this question more often?
1. Service-based firms, TCS, Infosys, Wipro, test your ability to create non-sensitive mock datasets. 2. Product companies, Salesforce, Atlassian, value realistic data generation for testing SaaS workflows. 3. Startups, prefer engineers who can simulate production-like data for QA and staging environments. 4. Cloud and QA automation firms, focus on integrating data generation scripts into test pipelines. 29. How can you containerize a Python test automation setup using Docker and run tests with PyTest? Answer. Good answer. You can create a Docker file that installs Python and your project dependencies, then run PyTest inside the container. Review of the answer. This answer is correct but basic. It does not mention environment consistency, dependency isolation, or how this helps CI/CD pipelines. A stronger answer must show why containerization helps maintain reliability across different systems. Better answer. Use Docker to ensure consistent test environments across machines. By containerizing your Python testing environment, you ensure that the same dependencies, Python version, and libraries are used everywhere, on developer machines, staging servers, and CI/CD pipelines. You write a Docker file that installs Python, pip dependencies, and PyTest. Then, running tests becomes a single command like docker run test container. Review of the answer. This version explains practical value, consistency, reproducibility, and clean isolation. But we can push further by integrating this into automated CI/CD workflows. This Docker file builds a container that runs PyTest automatically. Disclaimer: always test code in a non-production environment. This line selects a lightweight base Python image. It ensures the same Python version is used everywhere, preventing environment mismatch issues. This sets the working directory for the container, so all commands and paths run consistently inside/app. This command copies your project files into the container, including your test scripts and application code. This code installs all required dependencies from requirements.txt, ensuring the test environment has everything needed. This line runs PyTest automatically when the container starts. The Q flag prints clean test output suitable for CI logs. Best answer: integrating containerized tests into CI/CD pipelines. In a real CI/CD pipeline, the test container is built before deployment. The pipeline runs Docker build and then executes the container. If tests fail, the pipeline stops immediately, preventing faulty code from reaching production. This creates a reliable automated quality gate. Review of the answer. This answer connects testing to real DevOps workflow, reproducibility, pipeline enforcement, and automated failure prevention, showing complete operational awareness. This code snippet shows how CI/CD pipelines run containerized tests. Disclaimer: always test code in a non-production environment. This command builds the Docker image using the Docker file and names it testrunner for reuse in pipelines. This command runs the tests inside the container. The RM flag ensures the container is removed after execution, keeping the environment clean. Curveball: what if dependencies differ between environments? I ensure deterministic builds by pinning dependencies in requirements.txt, for example, PyTest is equal to 7.4.0. If the project uses system-level dependencies, I install them inside the container using apt-get. This ensures the environment is fully reproducible and prevents version drift issues. Why interviewers ask this question most often? This question checks your understanding of environment consistency, a core DevOps principle. It shows whether you can make tests reliable, repeatable, and pipeline-ready. Containerizing test environments is a key skill for modern QA automation, DevOps, and SRE roles.
Which companies ask this question more often?
1. Product companies, Atlassian, Salesforce, ServiceNow, expect repeatable CI test environments. 2. Cloud service teams, AWS, Azure, Google Cloud, emphasize environment reproducibility. 3. Startups, rely heavily on containerized automation for rapid release cycles. 4. Service-based firms, TCS, Infosys, Accenture, test whether you understand Docker basics for DevOps workflows.
30. How do you build a reusable Python automation framework with logging, CLI arguments, and modular structure?
Answer. Good answer. You can create reusable Python automation scripts by separating code into functions and using modules. Review of the answer. This is correct but lacks depth. It does not show how to make the code maintainable, production-ready, or team-friendly. Interviewers expect structure, logging, argument parsing, and repeatability.
Better answer. Organizing code into modules with logging and argument parsing.
To build a reusable automation framework, I structure the project into separate modules such as utils, config, and workflows. I use Python's built-in logging module to record execution details instead of print statements. I also use argparse so the script can accept input parameters dynamically. This allows different automation tasks to reuse the same functions across multiple scripts. Review of the answer. This shows good awareness of maintainability, but a demo with structure clarity makes it stronger. This is the folder structure of a reusable Python automation framework. Disclaimer: always test code in a non-production environment. This directory groups reusable helper modules, keeping your automation logic organized and modular. This file contains common file handling utilities, for example, reading configuration files or managing log directories. This file stores reusable network or API call functions, preventing duplication of request and retry logic across scripts. This config file centralizes environment variables, API endpoints, and timeouts, making the framework easier to update or migrate. This directory stores automatically generated runtime logs, which help in debugging, tracing failures, and auditing automation runs. Here is main.py, which uses logging and argparse to run tasks in a clean and reusable way. Disclaimer: always test code in a non-production environment. This line sets up logging so output is written to log/run.log instead of using print statements, providing traceable execution logs. This argument lets the script receive the target server from the command line, making the tool reusable for different environments. This calls a reusable helper from utils.file_ops, centralizing file operations instead of duplicating code in multiple scripts. This line delegates network connectivity checks to utils.network_ops, demonstrating clean separation of concerns. This final log entry confirms successful execution, helping with audit trails and debugging. Here is utils/file_ops.py containing reusable file functions. Disclaimer: always test code in a non-production environment. This ensures safe and clean file access using context management. Here is utils/network_ops.py containing network-related automation helpers. Disclaimer: always test code in a non-production environment. This line runs the system's ping command once for the specified address and captures both standard output and error output for controlled handling. This line interprets the ping command's exit status. A return code of 0 indicates success, so the function returns a clear, human-readable result.
Best answer: framework-level reusability and CI/CD integration.
I package the framework so CI/CD pipelines can call it automatically. Instead of writing new scripts each time, I only change parameters or config files. This ensures consistent automation across environments, faster onboarding, better collaboration, and reduced errors. Review of the answer. This shows organizational thinking, the ability to build reusable tooling instead of one-off scripts.
Curveball, what if different teams need different settings?
I externalize environment-specific values into config/settings.py or environment variables. The code remains unchanged, only configuration shifts. This prevents duplication and ensures the same framework adapts to multiple environments like dev, staging, and production.
Why interviewers ask this question?
This question evaluates whether you think like a developer who is preparing for long-term automation, not just scripting one-time tasks. Reusability, modularity, logging, and CLI support are foundational skills for DevOps automation roles.
Which companies ask this?
1. DevOps-driven teams that maintain large automation tool chains. 2. Cloud and infrastructure companies where reliability matters. 3. Product-based firms that emphasize maintainability. 4. Startups that need scalable automation quickly.
31. How do you compare expected versus actual results from test runs using Python, JSON compare logic?
Answer. Good answer. Load both expected and actual JSON files and compare their values to find mismatches. Review of the answer. This is directionally correct but lacks specifics. Interviewers expect you to demonstrate file-safe loading, clear mismatch reporting, and a path to handle nested JSON. A stronger answer shows a basic flat comparison first, then a deep, path-aware diff for real projects.
Better answer, file-safe loading and flat key-by-key JSON comparison.
A simple starting point is to load expected and actual JSON into dictionaries and compare values by key. This approach works when the JSON structure is flat or when you only care about top-level keys. The script should print a clear summary so CI logs are readable. Review of the answer. This is production usable for flat results, for example, test summary metrics. To impress further, add a deep comparison that walks nested structures and produces path-aware differences. This code snippet loads 2 JSON files and prints key-level mismatches for flat comparisons. Disclaimer: always test code in a non-production environment. This line opens the expected results file using a context manager so the file handle is closed safely after reading. This line parses the expected JSON content into a Python dictionary for in-memory comparison. This line opens the actual results file produced by the test run. This line parses the actual JSON results into a dictionary with the same shape as the expected file. This loop iterates through every key in the expected results so each value can be checked against the actual dictionary. This condition flags a mismatch when the actual value differs from the expected value for the same key. This line prints a clear summary header for CI logs so failures are easy to spot. This line confirms a full match when the mismatch list remains empty.
Best answer, deep, path-aware JSON diff with nested dicts and lists.
For real-world test reports, for example, API payloads or complex test artifacts, you need a deep comparison. A recursive function can walk nested dictionaries and lists, record exact JSON paths of differences, and write a machine-readable report. This scales from small unit tests to full integration regressions. Review of the answer. This is interview-grade quality. It handles nested structures, distinguishes type mismatches, reports missing or unexpected keys, and produces a file artifact for CI/CD auditing. This code snippet performs a deep JSON comparison and writes a path-aware diff report. Disclaimer: always test code in a non-production environment. This function definition introduces a recursive comparator that tracks the current JSON path and appends human-readable differences to a list. This line detects type mismatches early, for example, dict versus list, and records a clear diagnostic message. This branch handles dictionary comparison by walking keys and recursing into child values. This condition reports a missing key on the actual side to distinguish absence from value differences. This branch compares lists, first checking lengths, then recursing element by element with indexed paths. This line records a leaf-level value difference when both sides are primitive types and not equal. This line in main parentheses reads the expected JSON document to begin the comparison. This call kicks off the deep comparison from the root path, collecting all differences into the diffs list. This line opens a report file and writes every recorded difference on its own line for CI artifact retention. This line produces a concise summary in console logs and points engineers to the full diff report for details.
Curveball: what if arrays are order insensitive or contain large objects?
If list order does not matter, normalize lists before comparison by sorting them on a stable key or by converting lists of primitives to sets. For large objects, compare only selected fields, for example, IDs and timestamps, or compute hashes for performance. These adjustments reduce noise and make diffs actionable in CI.
Why interviewers ask this question most often?
This question tests whether you can turn raw test artifacts into clear pass or fail signals. Strong answers demonstrate safe file handling, readable diffs, nested structure awareness, and CI-friendly reporting, all essential for DevOps and SDET roles.
Which companies ask this question more often?
1. Product teams, Atlassian, ServiceNow, Salesforce, emphasize clear, audit-friendly diffs. 2. Cloud and platform teams, AWS, Google Cloud, Azure, expect nested JSON validation for APIs. 3. Service firms, Infosys, TCS, Accenture, value reusable comparison utilities in pipelines. 4. Startups, prefer lightweight, scriptable diff reports over heavy frameworks.
32. How do you integrate Python tests into a CI/CD pipeline, for example, Jenkins, with reports?
Answer: good answer. You run Python tests using PyTest and configure Jenkins to execute them during the pipeline. Review of the answer: this answer is correct in direction but not complete. It does not explain how reports are generated, archived, or displayed in Jenkins. Interviewers expect details about report formats, Jenkins pipeline steps, and how failures affect deployment flow.
Better answer: running PyTest with JUnit or HTML reports inside Jenkins.
I integrate Python tests into Jenkins by running PyTest with a reporting flag such as JUnitSym or an HTML report generator. Jenkins is then configured to collect and display the test results. If tests fail, the pipeline stops and prevents deployment. This ensures continuous testing. Review of the answer: this is solid and practically useful. However, it can be improved by showing pipeline-level automation and how test results become visible in Jenkins dashboards. This command runs tests and generates a JUnit-compatible test report for Jenkins. Disclaimer: always test code in a non-production environment. This runs all test modules inside the tests directory using PyTest as the test runner. This flag generates a JUnit format XML report that Jenkins can parse and display in the test results panel.
Best answer: Jenkins pipeline stage with automated reports and deployment control.
In a real CI/CD workflow, I integrate PyTest into a Jenkins file pipeline. The pipeline stage runs tests, publishes the test results, and marks the build as failed if tests fail. This ensures test quality gates before deployment. By archiving reports, teams can review results historically, track flaky tests, and maintain visibility across builds. Review of the answer: this demonstrates complete operational insight and CI maturity. It tightly links code testing, automation, reporting, and deployment control in one pipeline flow. This Jenkins file pipeline stage runs tests, publishes reports, and stops deploys on failures. Disclaimer: always test code in a non-production environment. This stage is dedicated to executing all Python test cases during the CI pipeline. This shell command runs PyTest and generates a JUnit XML report to be consumed by Jenkins. This directive tells Jenkins to publish the test results report so it appears in the Jenkins UI.
Curveball: what if tests pass locally but fail in Jenkins?
I would check for environment differences. This includes Python version mismatch, missing dependencies, different environment variables, or network restrictions. I ensure consistent environments using virtual environments, requirements.txt, or Docker containers. This eliminates works on my machine issues.
Why interviewers ask this question most often?
This question tests whether you understand how testing fits into CI/CD rather than running tests manually. Strong candidates show awareness of automated test execution, reporting, and deployment gating. It reflects real engineering responsibility, not just scripting ability.
Which companies ask this question more often?
1. Product-based companies, ServiceNow, Atlassian, Microsoft, emphasize continuous testing visibility. 2. Cloud and DevOps-focused teams, AWS, Red Hat, VMware, look for CI/CD maturity. 3. Service-based firms, Infosys, TCS, Cognizant, expect Jenkins and PyTest familiarity. 4. Startups, value pipelines that fail fast and prevent bad deployments.
Please check description or comments section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design interview questions and answers required for your Java or Python interviews, jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem-solving, interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section. These questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
33. Your automation script works locally but fails in CI. How do you debug environment drift?
Answer: good answer. Would compare the local environment with the CI environment to see what is different. Review of the answer: this is technically correct but far too vague. Interviewers expect you to explain which environment factors you compare and how you verify them. A strong answer should reference dependencies, Python versions, environment variables, system paths, and reproducible environments.
Better answer: compare Python version, dependencies, and environment variables.
When a script works locally but fails in CI, the most common cause is environment drift. I check 1. Python version differences. 2. Library versions, using requirements.txt or pip freeze. 3. Environment variables used in the script. 4. File paths and working directory assumptions. Then I reproduce the CI environment locally, usually by running inside a virtual environment or container. Review of the answer: this is now specific and realistic. It shows understanding of environment reproducibility. To fully impress, we show how to make the environment match exactly, using Docker.
Best answer: use a Dockerized runtime to eliminate environment drift entirely.
To fully prevent drift, I containerize the script using a Docker file that defines the exact Python version, dependencies, and runtime environment. The same container image is then used locally and in CI. This ensures predictable execution regardless of where the code runs. Review of the answer: this demonstrates complete operational maturity. Your solution prevents environment mismatch entirely, not just reacts to it. This is how DevOps engineers eliminate "works on my machine" problems. Here is a Python script that prints its environment details for debugging CI versus local issues. Disclaimer: always test code in a non-production environment. This function retrieves the exact Python interpreter version currently in use, allowing you to confirm whether local and CI environments match. This prints the path of the Python binary to confirm the correct interpreter is being used, virtual environment versus system Python. This object provides a list of all installed packages and their versions, which helps detect dependency drift between local and CI environments. This retrieves the value of an environment variable to verify whether C is missing required runtime configuration. Here is the Docker file that standardizes the environment for both local and C execution. Disclaimer: always test code in a non-production environment. This specifies the exact Python base image to ensure local and CI environments use the same interpreter. This installs dependencies from a pinned version list to maintain strict reproducibility. This defines the container's entry point so the script executes the same way in any environment.
Curveball: what if CI cannot run Docker due to security restrictions?
In that case, I use Python virtual environments along with pinned version dependencies, pip freeze requirements.txt, and ensure that CI installs exactly those versions. I also avoid relying on system packages by vendor locking dependencies wherever possible. This preserves reproducibility even without containers.
Why interviewers ask this question most often?
This question evaluates your ability to think like a DevOps engineer, identifying systemic issues rather than blaming the script. Real teams suffer from environment drift constantly, and the strongest engineers solve the problem at the root with reproducibility.
Which companies ask this question more often?
1. Product companies and platform teams, Adobe, SAP, Salesforce, strong emphasis on reproducibility. 2. Cloud and DevOps organizations, AWS, Red Hat, VMware, require deterministic build environments. 3. Service-based companies, Infosys, TCS, Wipro, expect knowledge of virtual environments and version pinning. 4. Startups, prioritize eliminating "works on my machine" failures early.
34. How can you monitor CPU and memory usage using Python?
Answer: good answer. You can monitor system performance using the SUDL library to read CPU and memory statistics. Review of the answer: this answer is directionally correct, but incomplete. Interviewers expect awareness of sampling intervals, continuous monitoring loops, and usable reporting output. A stronger answer must show how metrics are collected, formatted, logged, and optionally alerted on when thresholds are crossed.
Better answer: sampling metrics periodically using SUDL.
The SUDL library provides functions to read CPU utilization, RAM usage, and process statistics. A basic monitoring loop can collect data every few seconds and print or log it. This approach fits lightweight monitoring or local automation tasks. Review of the answer: this answer is practical but still lacks operational context. To make it production-ready, we add threshold checks and condition-based alerts. This code collects and prints CPU and memory usage at regular intervals. Disclaimer: always test code in a non-production environment. This line measures CPU usage over a 1-second sampling interval for accurate utilization readings. This line retrieves the current memory usage as a percentage of total system memory. This line pauses execution to avoid excessive polling and control how often metrics are sampled.
Best answer: monitoring with threshold alerts and logging.
In production, monitoring scripts do not only print values. They compare metrics against threshold limits and trigger alerts if resource pressure exceeds acceptable levels. CPU and memory limits vary per workload, but thresholds help detect overload, leaks, or abnormal spikes. The script below logs values and raises alert conditions, which can later be integrated with email or webhooks. This code logs CPU and memory usage and prints alerts when thresholds are crossed. Disclaimer: always test code in a non-production environment. This line configures logging so all metric data is stored in a persistent log file for later analysis. This line defines the maximum allowed CPU usage before the script triggers a resource warning. This line detects when CPU usage crosses the defined threshold and produces a warning for operational visibility. This line records CPU and memory metrics in the log file for tracking trends over time.
Curveball: what if the monitoring needs to run continuously without interruption?
In that case, I would run the monitoring logic as a background service or Docker container, and add exception handling to protect against script termination. For example, wrapping the loop in a try-except block and restarting on failure ensures reliability.
Why interviewers ask this question most often?
This question evaluates whether you understand resource monitoring fundamentals. Monitoring is a required skill for DevOps and reliability engineering, the ability to detect system pressure before failures occur.
35. How can you send daily system health reports via email using Python?
Answer: good answer. You can collect CPU and memory usage with SUDL and send the information by email using smplib. Review of the answer: this answer identifies the correct libraries but lacks execution detail. Interviewers want to see automated scheduling, structured reporting, and safe SMTP authentication. A stronger answer must demonstrate collection, formatting, and reliable delivery of reports.
Better answer: collect metrics, format the report, and send over SMTP.
You can gather CPU, memory, and disk usage using SUDL, assemble them into a readable text report, and send the report using Python's email and smplib modules. The script should run daily using cron, Linux, or Task Scheduler, Windows. Review of the answer: this shows practical workflow knowledge. To reach production quality, we now add credential safety and structured logging. This code gathers system metrics and emails a daily health summary. Disclaimer: always test code in a non-production environment. This line measures CPU usage over a controlled 1-second sampling interval. This line captures disk usage on the root file system, useful for detecting storage saturation. This line constructs a multi-line text summary that is easy to read in email form. This line wraps the report in a plain text email object suitable for SMTP transmission.
Best answer: schedule the report and store credentials securely.
In production, the script is scheduled using cron on Linux or Task Scheduler on Windows. For security, SMTP credentials are stored as environment variables or in a system secret manager rather than hard-coding them. Logs should be written to a file so failures can be audited. This demonstrates long-running reliability and operational safety. Cron entry to run the report daily at 8 a.m. Disclaimer: always test code in a non-production environment. This cron schedule means the job will run every day at 8 a.m. server time. This command executes the Python monitoring script using the system Python interpreter. This redirects both standard output and errors into a log file for traceability.
Curveball: what if email alerts are blocked by corporate firewalls?
In that case, I switch to webhook-based alerting such as Slack or Microsoft Teams, which use HTTPS and do not rely on SMTP ports. This ensures the reporting pipeline remains functional even in restricted environments.
Why interviewers ask this question most often?
This question tests your understanding of monitoring, reporting, scheduling, and credential safety. It demonstrates whether you can automate recurring operational tasks the correct way, not just print values to the console.
36. How can you automate database health checks using Python?
Answer: good answer. You can connect to the database using MySQL.connector in Python and run queries to check whether the database is reachable. Review of the answer: this is a correct starting point, but incomplete. A stronger answer must demonstrate what is being checked: connectivity, query response, replication lag, how failures are detected, and how notifications are sent.
Better answer: check connectivity, basic queries, and response times.
A basic health check includes verifying that the database can be reached, that queries run successfully, and that performance is within expected limits. Using MySQL.connector, we can open a connection, execute a simple query such as select one, and log whether it succeeds. Review of the answer. This demonstrates functional verification, but does not yet include automated alerts or CI/CD integration. This script performs a basic MySQL health check. Disclaimer: always test code in a non-production environment. This line attempts to establish a connection to the MySQL database using supplied credentials. This executes a minimal SQL query that verifies the database is responsive and accepting queries. This calculates the query latency to detect performance degradation. This section logs any connection or query error as a failed health check event.
Best answer: automate recovery and send alerts.
To make this production ready, the script should send alerts when failures occur and optionally trigger an automated recovery step such as restarting a database service or failing over to a replica. Alerts can be sent via Slack, email, or monitoring dashboards. This approach ensures the system does not rely on manual intervention. This version sends alerts to Slack when the database is unreachable. Disclaimer: always test code in a non-production environment. This line stores the Slack webhook URL used for sending incident notifications.
Curveball: what if the database is running but slow?
In that case, I measure query latency and set thresholds. If latency exceeds the threshold, I send a warning instead of a failure alert. This helps detect early signs of performance degradation rather than waiting for an outage.
Why interviewers ask this question most often?
This question evaluates whether you understand both application health and production reliability. Automating database checks is a core responsibility for DevOps and SRE roles.
37. How do you containerize and run a Python automation script using Docker?
Answer: good answer. You can write a Docker file that installs Python, copies your script, and runs it. Review of the answer: this is technically correct, but too shallow. It does not address dependency pinning, working directory setup, environment variables, or how to run the container consistently in CI/CD.
Better answer: define a reproducible runtime environment using Docker.
To containerize a Python automation script, you create a Docker file that specifies the Python runtime version, copies the script and requirements, installs dependencies, and declares the default execution command. This ensures the script runs the same way on any system. Review of the answer: this demonstrates sound understanding of Docker basics, but does not yet cover environment configuration or real-world automation pipeline usage. Here is a Docker file that containerizes a Python automation script. Disclaimer: always test code in a non-production environment. This selects the exact Python version and base image, ensuring consistent runtime behavior everywhere. This sets the working directory inside the container so all commands run relative to /app. This copies the dependency file before other source code to optimize Docker layer caching. This installs pin dependencies listed in requirements.txt for deterministic builds. This defines the default execution step, so running the container directly launches the automation script.
Best answer: use environment variables and config files for flexible automation.
In production, we avoid hard-coding configuration inside the container. Instead, we pass environment variables at runtime. This allows the same container to work across dev, QA, staging, and production without modification. We also parameterize script execution so that different automation tasks can be triggered from the same container image. Here is how to run the container with environment variables. Disclaimer: always test code in a non-production environment. This command builds the Docker image using the Docker file in the current directory and tags it as Python automation. This runs the container while injecting configuration via environment variables instead of hard-coding values in code.
Curveball: what if the automation script needs files or credentials?
For files, mount them using Docker run $pwd /data:/app or data Python automation for credentials. Use environment variables, AWS IAM roles for service accounts, RSA, or secret stores like AWS Secrets Manager. Avoid copying secrets into the image because it makes them difficult to rotate and increases exposure risk.
Why interviewers ask this question most often?
This question checks reproducibility and deployment maturity. Strong responses demonstrate the ability to create consistent automation environments that can be smoothly moved across local systems, CI/CD runners, and production servers.
38. How do you build a reusable Python automation framework with logging, retry logic, and centralized configuration?
Answer: good answer. You can organize your code into modules, use logging instead of print, and keep configuration in a settings file. Review of the answer: this is correct directionally but too high level. Interviewers expect a clear explanation of folder structure, reusable utility modules, configuration loading, and retry patterns, because these are key traits of maintainable automation frameworks.
Better answer: separate workflow logic, reusable functions, and configurable values.
A reusable Python automation framework has a clear folder structure, reusable functions in util/, configuration in config/, logs and logs/, and entry scripts in root. Logging replaces print statements for traceability, and retry logic is centralized so that any network or file operation can be retried safely. Review of the answer: this version demonstrates good architectural awareness but still lacks an example that ties everything together. Here is the folder layout for a reusable automation framework. Disclaimer: always test code in a non-production environment. This module stores common network automation functions so they can be reused across different scripts. Here is util/retry.py containing generic retry logic. Disclaimer: always test code in a non-production environment. This loop controls how many times the operation will be attempted before giving up. This executes the past in operation and returns its result when successful. This catches any runtime failure during the operation so retrying can occur. This introduces a delay between retries to avoid rapid repeated failure loops. Here is util/network_ops.py using the shared retry logic. Disclaimer: always test code in a non-production environment. This imports the shared retry handler so network logic does not need to re-implement retry patterns. This reads the API endpoint from a centralized config instead of hard-coding URLs in multiple files. This inner function contains the actual network call, allowing retry parentheses to execute it multiple times if needed. This passes the network call into the retry logic wrapper to ensure reliability. Here is main.py tying logging, config, and reusable logic together. Disclaimer: always test code in a non-production environment. This configures logging output to a timestamped file instead of printing to console.
Curveball: what if the framework must support multiple environments, dev, QA, prod?
I store environment-specific config in separate settings files and select them using environment variables or command line flags. This way, the same automation codebase adapts to multiple environments without modification.
Why interviewers ask this question most often?
This question tests whether the candidate can structure automation in a scalable, maintainable way. Strong answers demonstrate code reusability, runtime flexibility, logging discipline, and reliability via retry patterns, all of which distinguish skilled DevOps and SDET engineers.
Please check description or comment section of this video. I have given a lot of links for downloading 6 PDFs in a single zip file, containing all types of most asked interview question and answers like scenario-based, technical-based, behavioral-based, real-world problem-solving, generally most asked and system design interview questions and answers. Required for your Java or Python interviews, jobs like Java Application Support Engineer jobs, Site Reliability Engineer (SRE) jobs, AWS Java Developer jobs, AWS Python Developer jobs, Java Kubernetes Developer jobs, Python Kubernetes Developer jobs, Java Backend Developer jobs, Application Security Engineer jobs, Python DevOps Engineer jobs, Java DevOps Engineer jobs, etc., etc. These questions and answers are carefully curated by industry experts, saving you people hours of research and ensuring you people will have the most accurate and relevant answers. This PDFs includes scenario-based questions and answers, real-world problem solving. Interview questions and answers where almost 80% of the people are failing to answer, system design questions and answers where almost 90% of the people are failing to answer, with detailed solutions, which are often missing from free online resources. A lot of people are claiming that these questions are coming in real interviews. So, grab them as soon as possible with both hands. Since these questions and answers covers basic to advanced interview questions and answers, that's why given 50 question and answers for each section, these questions and answers will be helpful for freshers, 2 to 3 years experienced people, and 5 or above years experienced people also for your interviews. You people can download all 6 PDFs in a single zip file from below given links.
For more exciting tips, tricks, and more importantly, for valuable insights of interviews, please share, like, and subscribe to my channel. It has a lot of valuable information about various insights of interviews. It has a wide range of real-world portfolio projects of various technologies for interviews, and it has wide range of most asked interview questions and answers of various technologies like data science, SAP, AWS, DevOps, and full-stack web development, and more. That will be useful during interviews. It has a wide range of most asked interview questions and answers and real-world portfolio projects of various technologies for freshers, for 2 to 3 years, experienced candidates, and for 5 or above years, experienced candidates to test their skills by knowing most asked interview questions and make themselves ready for interviews.